Well, hello Internet and welcome to my Golang full course video tutorial. You guys asked me to cover just about everything with Golang, and this video I am going to do it. This is the longest video I've ever made. This is just a brief sampling of everything that will be taught. In the description underneath you'll find all the code. It's on GitHub for free. And also, there are no ads for the rest of this video, and you'll be able to jump around and to all the individual pieces you want to learn, or you can go on GitHub and get all the code. So why use Golang, or why even learn it? It is a fantastic general purpose language that is very easy to understand and write good code with. Right out of the box, yeah, there might be languages that are faster if you program them perfectly, but with Go you will very often find that you can write extremely fast code without having to worry about doing everything perfect, which is great. It's a great back-end language. It excels at concurrency. It has many built-in features, strong typing, handles memory for you easily, fast compile times, and cross-platform. And I have a lot to do, so let's get into it. Alright, so I'm going to be using Visual Studio Code for this, and the name of our file is going to be hellogo.go, but we're going to be making a whole bunch of different files. And there's no ads for the rest of this video, no sponsorships or anything, just so you can focus 100% on education. And so you just want to create a directory somewhere and name a file hellogo.go, or you can name it whatever you want. And we're going to jump in here, and the installation part is at the very end of the video so as not to distract. First thing we're going to do is I'm going to get into packages and modules and all this stuff later on in the video, but for right now I'm going to keep it very straightforward. Now, a package is just a collection of code, and we can define what package we want our code to belong to by just saying package main, for example. We're going to be using other different names, but whenever we use main, that means that this is code that is going to be run in our terminal. So now what we need to do is go and import some packages that we are going to use. And I'm going to just import all my packages all at one time. So I'm going to go import, and I'm going to say format like this. Now, very often, of course, we're going to want to be able to print out to our terminal. And you're going to use a command called printline, or print, there's a whole bunch of them. And I am going to abbreviate this so that I don't have to every single time type in format dot print. Well, it didn't pop up with a shortcut. Oh, that's because it didn't get that yet. Okay, instead of typing all that out, what I'm going to do instead is I'm going to create an alias. And you can do this for everything, just don't get crazy. So I'm going to use PL as my alias for print line. So anytime you see print line like that, or PL, you're going to know that it refers to that. And we do not have semicolons, but you can use them if you really want to. A comment is just going to be 2 slashes like that, or you can have multi-line comments. So let's do a multi-line like this and like that. And you can jump through to all the different parts of the video if you only want to learn a specific part, of course. So what do we want to talk about first? Well, the most important thing for us to get an understanding of is our main function. So whenever a Go program executes, it specifically looks for a function called main, and that's where it begins its execution. And you're going to define all your functions by typing in func and main, like, well, not everyone who's going to be called main, of course. And we're going to define our main function. Now, if we just simply want to come in here and do our traditional hello world, maybe we instead want to come in and say something like hello Go, we can do that like that. And I have Code Runner running inside of here. You can just come up here and run this, and you're going to see hello Go pops up right there. All right, very simple stuff. Now, let's say that we want to instead get some user input and do something a little bit more creative. Well, inside of here, I'm going to say something like, what is your name? And I am then going to go and get some user input. So I'm going to call this reader, and I'm going to go buff.io dot new reader. And what this does is it sets up a buffered reader that gets text specifically from our keyboard if we type in os.standard.in like that. And you can see there's little errors here. That means we need to import buff.io. So let's just go buff.io like that. And then let's also go os like that. And we can get these in here and just paste this down here and this down here. All right. So there we go. Now we got all those set up. Now what I want to do, and the error here is saying, hey, you declared this, but you didn't use it. If you are aware of Rust, there are some similarities in regards to what is and not considered best practices with Go. All right, so we got that all set up. So what I want to do now is I am going to say that I'm going to store this input inside of name, but I also want to protect that some type of error occurring. And I'm going to do that by following the comma up here with an error that could potentially occur, and then I want to handle it. So I'm just going to then call our reader and go read string, and I am then going to say that I'm going to read up until the point in which we get a new line, or the user inside of the terminal hits the enter key. Now, if I didn't want to get the error, I could just go and use what is called the blank identifier, but that's considered a bad practice. So instead, I am going to handle my error instead of ignoring it. So I'm going to say if the error is equal to nil. Well, in that situation, I know I did not get an error. More on the specifics of why I know that, but just understand that if nil is passed back, that means there was no error. I'm then going to follow that up with the name that they gave me. And otherwise, I'm going to say else. I'm going to go log.fatal, and I'm going to display my error message and handle it. Again, normally whenever you see those little squiggles, that just means that we need to go and import a new library. All right, so we have that all set up. Let's run it and test it out. So what is your name? And it's Derek, and there you go. Hello, Derek. All right, and so we move on from here. Next thing I want to talk about are variables. And normally with a variable, you're going to define, or you're going to put var like that every time, and then you're going to say whatever the variable's name is, followed with the type. And the name must begin with a letter, and then it is allowed to contain letters or numbers. And one thing to know is if a variable, function, or type starts with a capital letter, it is considered exported and can be accessed outside of the package. And otherwise, if it's lowercase, that means that we're not going to export it. More on that later. Don't worry about knowing the specifics of that. So let's come in here and let's create a variable. And I'm just going to go vname like that. And I'm defining what data type it is, which is a string. And then I am going to just type in my name like that. And you can see everything is set up here. And something else you may notice is camel case is used for our naming conventions inside of Go. Let's go and create, let's say you wanted to create multiple different variables. Go v1 and v2 is equal to 1.2 and 3.4. Something else that's legal to do, those little squiggles just mean that I defined but did not use those variables. Everything else is cool. All right, let's go and create another one. Let's go v3 and define this as hello. This is a situation in which we are asking our compiler to go and figure out the type for us, which it will gladly do. And variables are mutable by default. That means values can change as long as the data type is the same. So you can't go and create a variable called a string and then store a string inside of it and then change it to an integer. Doesn't work that way. Another thing you could do is get rid of the var part and say something like vr equal to 2.4. And again, it's just going to automatically go and define our data type. And after you're declaring variables to assign values to them, you're always going to use an equal sign thereafter. So this is okay whenever we are initially assigning a value, but later on, if we want to assign a value to it, we have to go equal to 5.4 or something like that. And you'll see if we come in here and use this instead, that is going to give us an error. And I think that's enough on naming conventions of variables. Now let's go and talk about data types. Now the core data types are going to be ints, float 64s, bools, strings, and runes. Are there other ones? Yes, there are. We're not going to talk about those quite yet, though. They're going to have default values, ints of 0, floats of 0.0. Booleans are going to be false. Of course, booleans have true or false values. And strings and runes are just going to be empty values with nothing inside of them. Let's go in. We can say something like we want to go and check out the different types. So we can say type of, like that. And we want to find out what 25 is inside of here. You can see we are getting an error right here, and that just means we need to come up here and throw this in here again. So, whoops, so reflect, and we can use that as well. And you can see that the unused libraries disappeared. And we'll go and throw some other different types of data inside of here. So let's do 3.14. And we'll do true, and we will do hello, and you can store all kinds of weird things inside of here. Let's get rid of that and type in hello instead. You can even go and do some sort of like graphic if you would like. Let's just throw something silly inside of here, like that, for example. Okay, and we're going to save this. And I'm going to just go CLS to clear that and run it. And you're going to see all the different data types that we have under these circumstances. Okay, so basics of data types. More's coming, and you're going to learn more about different data types as we continue. But now I want to talk about casting because it's very important. Now, to cast, all you're going to need to do is, let's just go and create a variable like this. Well, let's call this CV1 and go and allow the compiler to find the data type for this. And we'll go CV2, so ZV2 and equal to. Now, if we want to go and get this float and convert it into an integer, all you need to do is put whatever type you want it to become on the outside of the parentheses, and that's what it'll do. It'll automatically go and convert that for you. And we come in here and go CV2 like that and run it, and you're going to see that this is just going to knock off the decimal part of our number. Now let's come in and define CV3 and equal to, and we'll just throw in a great big number, so 5 like that. And let's say that we want to go and convert this. Let's make it a string. So we'll change that into a string. And we want to convert this string into an integer. Well, we can go and say we want to store this in CV4. And we're going to protect against any errors that we might get. And we're going to go string convert. This is going to be another library we need. So string convert like that, and then we follow that up with ASCII to integer is what this stands for. ASCII to integer and CV3 like that, and then we can say PL and CV4. Instead of handling this error, let's go and just pass this out inside of here, and I'll go reflect and type of and CV4 and jump up inside of here and go reflect again and go and run this guy as well, and you'll see that nil came back in that circumstance with our error. And I just wanted to show you that as a change of pace, different thing. And you can also see we successfully were able to convert our string type into an integer type, as you can see right there. Now, if you would want to convert an int into a string, let's just call this CV5. All the code is available on GitHub, by the way. I guess I probably should have said that earlier. And you can go and download it for free, and there's a link in the description. So CV6 is going to be, and we'll just get rid of this altogether, and we will go ITOA, and this is integer to ASCII. That's what that means. And this is going to be changed into 5, and then we can come in here and just print this out. So we go like this, and CV6 like that, and run it. And you can see it comes back right there. Let's say we would want to convert a string to a float. How would we do that? Let's go change this into CV7 and get rid of this part. Change this to 3.14. And let's go get rid of this altogether. And what I want to do is I want to handle a potential error. I'm going to say if. We'll get more into if statements later on, but if you're learning Go right now, Go is normally not a first language, so I think that the chances are you've probably seen an if statement before. So we're going to go parse float. I'm going to get rid of this so I have more screen real estate to work with. Maybe move that over a little bit. So I'll say parse float and CV7 64, and I can go error equal to nil. So I'm going to do the error handling right here, and I'm going to go PLCV8. So there's another way of handling an error if you would like multiple ways, and there are multiple ways. And you can see here is our float, and we can also do some formatted printing. If you wanted to go and actually convert a or put a float and convert it into a string, we could do something like CV9 like this and call format.s print f, and then if you're using floats, you're going to use a %sign and f. I'll get more into these printf types of formatted printing later on in the video, actually pretty soon. But F just stands for float. D is going to be used for integers, and I'll get into the other ones as we go. But if you wanted to convert from float to string, that is exactly how you do it, and the value would be stored inside of this variable right here. All right? So that is a whole bunch about casting. And now what I'd like to do is talk about the if conditional. Now I'm assuming you have a basic concept of how if statements work, and so I'm not going to cover them in massive detail. I'm just going to get into the specifics that are used with Go. All right, you're going to have the conditional operators you're always using. Greater than, less than, greater than or equal to, so forth and so on. And this is not equal, and of course this is equal. We're also going to have logical operators. So this is going to be and, or not. Okay, so those are going to be the operators we are going to use whenever we are performing different conditional logic. Now what I'd like to do is I would like to receive an age, and I would then like to decide if a birthday is going to be important or not based off the age. I'm going to say anyone who is 18 or under is going to have an important birthday, and anyone who is 21 or 50, that birthday is important, and then anybody who is over the age of 65, their birthday is important, but everybody else, your birthday isn't important. Okay? So I'm just going to come in here like this, and how we would structure this is I'm going to say if I age is greater than or equal to 1. Now if I want to have multiple conditions that have to be true for us to be able to proceed, I'm going to put an and sign inside of there, and I'm going to say less than or equal to 18. Okay, and what I'm going to do here, I'm just going to say that this is an important birthday and print it on the screen. So important birthday. There we are, and I'm going to copy this because I will need it. What else? Well, we can stack our conditions. So I can say if this wasn't true, then I'm going to say if the age is equal to 21 or the age is equal to 50, well, I'm going to say those are important birthdays also. So I'm going to paste that in there. And then I'm going to stack another one on. I'm going to say else if the age is greater than or equal to 65, well, then that's an important birthday. And else, this is going to be the default. If none of the other ones are true, I'm going to say that anyone who is not in any of these other conditions, not an important birthday. Alright, sorry. Okay, and let's run that. And if we do, it's going to come back important birthday. Why? Because the person was 8 years old. Now, the not conditional is just going to turn the booleans into their opposite value. Now, a boolean, of course, is either going to have a true or a false value. That is it. Those are the values for bool. So you would use the not normally in conditionals, very often in loops and things like that. You're just going to say, let's use not on the value for true. And if you are using print line, you do not need to put a space here. There's a space automatically added at the end. Just specifics. If you're seeing weird stuff, well, that's why it's weird. And we can run this, and of course it's going to come back as false. All right, so there you go. There is a little bit of conditional logic. More is coming. Now let's talk about strings. All right, so let's go and create a string. And I'm just going to allow the compiler to figure out that this is a string by using :equal. And strings are just going to be arrays of bytes, which are going to actually look like this, which we'll get more into later on. But that is basically what a string is. Now, let's say that I would like to come in here and get the letter A and replace it with the word another. Well, to do that, we are going to use what's called a replacer equal to, and I'm going to say strings. It's going to give me an error message. That's because I don't have the strings library. So strings like that. And I'm going to follow this up with new replacer. And I'm going to say, hey, anywhere you see, whoops, this is going to be strings dot. Anywhere you see an A, what I'd like you to do is to place another there instead. All right, and that is going to work for us. And then what we can do is we can use this replacer to come in and replace those values. So we'll say replacer dot replace and SV1. And then we could go and output this if we would like. So SV2 like that. Let's go and do something, a couple more, so we don't constantly run here and we get some more stuff. All right, let's say you would like to get the length for a string. You're going to use len almost every single time, everywhere you want to get the length of anything. Let's say we would like to come in and find out if a string contains another string. We can say contains another, for example. So we'll say, does this string contain the word another? And then we're just going to follow that up with strings dot contains, and we'll pass in the string we want to search for, and then we'll follow that up with what we are specifically searching for. And open this up a little bit. Doop, there we are. Let's go and do a couple more here. Let's say that we would like to find out, or we would like to get the first index match for a letter O. So we'll say PL like that, and I'm going to say O index, just to keep it nice and short. And I can say strings dot index SV2, and we're looking for the letter O. What else can we do? Whoops, I accidentally stole that parentheses. Let's say we would like to replace all matches of the letter O with a 0, just for the heck of it. So we'll do PL, and I'm going to say replace, so we can see what this looks like. And I'm going to say strings dot replace, typing a little fast here. The string we want to work with is this one, the one we've been playing around with. And we want to search for O's, and we want to replace them with zeros. And I'm going to type in -1. And this is going to search everywhere. And if I had like a 2 or something like that, it's going to replace the first 2 matches. So that's what that last part is. But I'm going to replace everything by putting -1 inside of there. Let's say that I would like to remove whitespace characters. I'm going to create a new string. Let's go SV3 like this, equal to, and the white spaces I'm going to use are going to be new lines. I'm just going to go some words like that, and then maybe throw another new line. You're going to see more with new lines. It just goes and causes the terminal to jump to the next line. And there's a couple different, these are called escape sequences. Anytime you see a backslash with an N, that's an escape sequence. And you also have things like tabs, or let's say you would want to put double quotes inside of double quotes, you know, inside this string, for example. You could do so if you go and escape them. You just do it one time. And let's say you'd like to do a backslash inside of a string. You just go like that. All right, so there's those. And I wanted to, got a little distracted. Let's go and get rid of this white space. You can go and save it back into the original string by going sv3 equal to, remember, whenever you do assign a string a second time, you always use this regular assignment operator. So I'm going to go and call strings and trim space and sv3, and it knows to get rid of all of the white space that we have inside of there. Just make sure you give it the proper name. Let's say that I go and, well, let's just create something. So I'm going to say that I want to split on a delimiter, and a delimiter is just a common thing that is used in a string to separate the information. So I'm going to say split like that, and I'm going to go strings dot split, and the string I'm going to be working with is A-B-C-D, and this would be the delimiter, why it separates all the individual pieces of data. And that's what a delimiter is, and I'm going to define what the delimiter is, and it's going to just get rid of all those delimiters and then just give me just the letters. Also, we're going to be able to come in and let's say we'd like to convert something into lowercase or something. So we'll go like this and lower and get our string. So we'll go strings dot to lower and sv2. And we're going to do the same. We can convert everything into uppercase. And this works, or is very useful anyway, very often whenever you're just analyzing strings. And we'll do upper in this situation. So upper. And what else? We're going to be doing more using other different string functions as the tutorial continues. I just wanted to give you a rough overview of a whole bunch of them here, and don't dwell on it too much. Let's say that we would like to look at a string and see if it begins with another string. That's going to be strings dot has prefix. That's the same as saying this is uppercase. Almost always these functions are uppercase. Why? Because they're exported from another package called strings, and the only way you can use them is if they're uppercase. If they were lowercase, you wouldn't be able to access them. It's just a rule inside of Go that you'll get more acquainted with as we go. And Taco Cat. Sounds like Go has a lot of different rules, but they're pretty easy. Once you play around with the language for a while, you're going to find that the rules actually make using Go easier instead of harder, which is sometimes true with other languages. So, and we'll just call this has suffix, and this just means that it is going to end with a specific string. So we'll say cat. And I think that's it for now. That's a good overview of a lot of different string functions. And there you go. You can see that the length of our string is 12. Does it contain the word another? Yes, it comes back as true. Where's the first index where we get an O, letter O? That's the second. You can see here we replaced all the O's with zeros. You can see here we split and created an array by getting rid of those delimiters. We went and used up lowercase and uppercase prefix, and it is true for both of those. All right. So there's an overview of a whole host of different string functions. And now I'd like to briefly talk about runes. Now in Go, characters are called runes. And runes are Unicodes that represent characters. So let's go and create this string that we have right here. I'm just going to go A, B, C, D, E, F, G. That's good. And I'm going to say that I want to count the number of runes. So I'll say rune count. And to do so, you go UTF-8, And of course, that means we need to come up here and go UTF-8, UTF-8. And then we will follow that up with ruin count in string. And then I'm going to pass in my string that I want to go and count. And let's say that I'm going to print out all of the ruins in the string using a for loop. This is the structure of a for loop. And it's just going to go for I in ruin val equals to range. And I'll briefly explain what this means. And basically what this is doing is it's just cycling through all of the letters inside of this string one by one. And this is going to represent our index for each of those strings, and this is going to represent our individual ruin value. And if we type range in front of a string, what that's saying is we want to get each of these letters one by one and do something with them. Okay? And the for loop is just a looping structure, just like it is in numerous other different languages. If that didn't totally make sense, I will be covering for loops in more detail as well as ranges in more detail. So another thing I'd like to talk about is a printf function. What this is it's just formatted printing, and it just makes it very easy for us to place our different variable values in multiple different places inside of a string. So the very first thing I want to do is I want to print the index. And now for this string, that's going to be 0 for A, B is going to be 1, and it's going to continue therefore forever. All right, so if I want an integer, I want to place an integer in this final string that is then going to be displayed. I'm going to put in %d. I'll do a whole bunch on printf and all the different codes, but I'm going to give it the overview here. Now, if I would then want a ruin Unicode to print out, I just go %, and I'm going to say the hash symbol and U. And then finally, if I would like to go and get the character to show up inside of there, just go %C. And whenever you're using printf, you have to put in a new line to have that show up. So there's our index. And what's going to happen is this guy right here is going to go right here in what prints out on the screen. And we're going to go ruin value. This guy right here is going to be printed where this is, where that string is. And then we will, what else? Oh, I'm going to go ruin value again. However, this time instead of a Unicode that's going to print out, it's just going to print out the character itself. And if we go and run it, we can go and... Oh, UTF-8? I thought I typed it in up here. Oh, I got ahead of myself. Let's get rid of this. Like that. And that like that. And now let's run it. And you can see how it prints out the Unicode along with the character itself. And the Unicode, representation. The character. And here we have our index. All right? So more on ruins as we continue. But now I'd like to briefly talk about how we can work with times. Now you're going to find that it's very often very useful to be able to get time information. And if you'd like to do that, well, first off, you need to go get your time library. And then inside of here, let's say that I would want to get the current time at this moment. So I say now, and then I just go time like this, and now. And it's going to give me all sorts of time information. So let's say that I would like to go and get my current year. I can just do now, year, and it's going to give me that. And I'm just going to print all these out together. I'm then going to say now, and let's say I want to get the month. Do that. And now dot day. And let's go and get some more information on the now that we're living in. I can then go and get the hour. So hour and second, you're going to find is very useful for getting or generating random values. Let's say I want to get the minute, and then finally the second. Get all of those guys and run it, and you're going to see that it is 2022 August 5th, and this is in military time that we have right here. So this is going to be 8:04 with 18 seconds. All right. So brief amount of information about time. And now what I want to do is I'm going to talk about some different math functions, and we will use time once again to come in here and generate random values. Now I'm not going to waste your time. Here is everything. Here's some basic operators. So if you want to add values and subtract, multiply, divide, and this is going to give us the remainder of some type of a division. That's what that is. All right, and also you can do shorthand incrementing. So for example, if I had something like m int, I wanted to add 1 to something called mint, I could do that. Well, let's go mint like this is equal to 1. All right. Now let's say I wanted to add 1 to it. Well, I could go mint is equal to mint plus 1, or I could go and get rid of this and put a plus sign like that and 1. Those are exactly the same. And then something else that is very useful is we're also just going to be able to go plus plus like that. And you're going to be able to do this with all of your different operators that you would have. Another thing, let's just go and get rid of all this. What's very, very important is to understand precision whenever you are working with float values. So let's go and just get an absolutely huge value like this. Okay, so these are gigantic. Whoops, let's go many, many, many floats. And you're going to see that this is going to hold the precision whenever we're doing those calculations, even though those are tons of decimal places. So that's very, very important to understand. I also said that I wanted to show you how to create random values. I'm going to use time to do this again. That's the reason why I covered time so early. So we're just going to come in here like this. And one thing that's important to understand is it's very useful to get a seed value for your random number generator that's based on seconds. And it's actually based off of seconds since the date 1/1/1970. That is the number of seconds since January the 1st, 1970 is what you're actually getting. I'm going to call this seed sex like that. And I'm going to go and get the now time. And then I'm going to go Unix like that. And this returns the seconds since January the 1st, 1970 and as an integer. And then you can use this as a seed value to generate random values. So we'll go seed seconds. There we go. And if we want to generate a random value from 0 to 50, let's go random number like that. We would call rand.int n and 50. But what this is actually going to do is generate random values from 0 to 49. It's up to 50, but not including 50. And then, so we just put a +1 on there, and everything's good. And then I can go and generate this random value. So we'll just go random like that, and random like that. And that is going to give us a random value. And if we run this, it's going to give us, there it's 30, and here it's 34, and it's just going to continue onwards and onwards. Now, there are numerous different math functions. These are probably the math functions you're most commonly going to use. I'm not going to go through all of the specifics. This is in our math library. I'm not using time anymore, so let's just replace that with math. There we are. And we're not using rand anymore either, so let's get rid of that. And you can see here are all of our different math operators. And some other things that might be kind of useful. Well, we can just run this. And you can see there's the math operators and how they operate. And another thing that might be kind of useful for you is, let's say you would want to convert 90 degrees into radians. Let's go like this. That's how you can do that. Another thing that you can do is, let's say you want to convert radians into degrees. Of course, we can do that also. And let's just go and print that out. So something like this and like that. Boom. So there we are, and run it. And you're going to see here that 1.57 radians is equal to 90 degrees. And then I'll get into, if you want these to show up as like 2 decimal places or something, you just put 0.2 inside of there like that. I'll get more into the specifics of formatted printing. Actually, I might do it next because I keep forcing myself. Say now it's just 2 decimal places instead of a whole ton of decimal places. And that's what that does there for us. And of course, there's going to be all the different trig functions you could ever want. So let's say you wanted to do the sine of 90. Let's go like this. This would be 90 degrees. But what I want is the radian version for 90, because the trig functions all work with radians, not degrees. So I'm going to say math dot sine and then pass R90, and that is the radian version of 90 degrees. And if we do that, you can run this, and it's going to come back as 1, as expected. And like I said, there are a whole ton of different trig functions. There are just about all of them, and also hypotenuse you're going to be able to get. And just remember, whenever you're using functions that come from different package libraries, they always end with a capital letter. All right? Very important. And whenever you start creating them, they also will have capital letters. And that is a lot of information on math functions. And now I would like to talk about formatted print. Now, Go has its own version of C's printf, and here are all the different codes we're going to use depending upon the different data types. And you've seen a good bit of them so far. This one right here is probably one of the weirdest ones, and it's just going to guess based on data type. We've seen that, I think, in a couple examples. But let's just come in here and let's go and use it. So we're going to say format, and we're going to say printf, and I'll just throw a whole bunch of these different symbols in here and then explain exactly what they do. This is going to be used for characters. This is going to be used for floats. So we have strings, integers, characters, floats. Then we'll have t inside of here, which is going to have type of the supplied value, like I said. And I'll just go and throw some more of these in here so you can see a whole bunch of examples. And remember to put a new line at the end here. And you can also just skip to the next line if you'd like. That is perfectly fine with Go. And then I'm just going to throw a whole bunch of things in here. So I'll throw in stuff as a string. 1A, 3.14, true, and 1, and 1. Oops, and then go and put this quote here, and go and get rid of that. Okay, so there we go. And if we run it, you're going to see all of those different data types all get placed inside of there. All right? And let's do some file format, or some formatting, because this is probably one of the more complex things. This isn't complex, though, by any stretch. Okay, so let's say that we wanted our output to have a total width of 9. What we could do, and that's just going to put spaces anywhere where we do not have anything. And we're going to do this with our floats in this circumstance. And, of course, this has to be in quotes. So there's the quotes. And then let's just throw 3.14 inside of there. And I'm just going to copy this so I don't have to do it again. And I'm going to show you a couple examples. I also showed you how to limit it to just 2 decimal places. And let's go and just add a couple more here just so we can see something. And let's go 1592. And also we can go and say that we want to get rid of the decimal place like that. And we can run this. And you can see how the formatting was applied. 9 spaces, you can see there's spaces that are placed inside of there. And here you can also see that all the additional spaces that are going to be required by us putting the 9 inside of there are going to go before the variable. And it just helps with setting some things up. And lastly, I already showed you this, but I'm going to show it again just to keep everything all condensed for the people that want to be able to jump around by just clicking on the table of contents in the description. So sprintf, what it's going to do is it's going to format a string and return it instead of putting it in output. So let's just say something like 9.f and a new line, and then follow that up with pi, like that. And then we can go and call for it to actually output onto the screen, sp1 like that, and run it, and you can see we get the same output. All right, so there's a rundown of some formatted printing. Like I said, as the tutorial continues, you'll see more of it. And now I want to go and cover for loops. Now, with for loops, basically what we're going to have as a standard setup, you're going to have your you're going to have the word for first. You're going to initialize a variable that's going to be used for cycling, maybe. you're going to have your condition that's going to determine how long we loop. We're going to have our post statement, which is normally going to be some type of incrementer. And then we're going to have inside of curly brackets the body of the for loop. And let me go, let's say we wanted to create a for loop that is set up to just print out the numbers 1 through 5. We can just go like this. And we're going to say we're going to continue cycling as long as x is less than or equal to 5. And then we're going to increment like that each time we go through our cycle. And that's first for loop example. Let's go and do, let's say you would want to do the opposite. Well, we can just run this. Okay, so why did it not print? Oh, I didn't save it. Okay, save it and run it again. And you can see it prints 1, 2, 3, 4, 5. Now, also, let's say we wanted to do the opposite. Well, we could just put a 5 inside of there, change this to greater than or equal to 1 in this circumstance. And then in this circumstance, we want to decrement. And let's run that. And you're going to see it prints in the opposite order. One thing that's important to understand is this X value right here, it is actually out of scope in main. So it only exists inside of the for loop. And most of the time you want that. So if you would do something like, say, you wanted to get X like this, and you wanted to print it out, that's going to give you an error. And that is because it doesn't exist. It only exists inside of our for loop. Let's get rid of that. For can also be used to create while loops. So let's do something like fx like this, and 0, and for fx less than 5. And then we can go PL and fx, and then increment the value for fx. And we can go and get rid of this guy so we're not confused by what's going on, and run it. And you can see that it went and printed all those values out as well. And why don't we do like a real thing here right now? So what I want to do is I want to create, using a while true loop, which is actually an infinite loop, and I want to go and create like a guessing game. So what can we do here? Well, we can use some of the things that we've learned about before. So we're going to go and get a seed that we're going to use for a random number generator. So we're going to say now, and then follow that up with Unix, and that's going to give us all values since January the 1st, 1970. Remember, we have to come up here, import that library. All right, so we have our seed value, and that just adds to the randomness of what we're doing. I need to use it, so I'm going to say ran.seed, and then throw in seed seconds, like this. Then after that, we can come in and generate a random value. And we're going to try to guess what this random value is. So we're going to say rand dot, and we want it to be an integer, and we want it to be 0 to 50. So +1 like that. And then what we can do is go for true. This is an infinite loop. It's going to continue to execute as long as, basically until we call a statement called break, which is going to throw us out of our loop. I'm then going to go and I'm going to call print on this, and that's just not going to have a new line at the end of it. And I'm going to say guess a number between 0 and 50. Then, just so that we know it, so that we can save some time, I'm actually going to print it out on the screen. So number this is a really bad guessing game if you were going to print the answer right there, but we're just going to do that just to save some time so we don't have to guess every single number. And we have these two errors. We have to put a little colon in front of here like that, so because these are being newly declared. Then after I do that, I'm going to go and actually get our random value. I'm going to call this guess, and then follow that up with error to handle that. And I'm going to go reader dot read string, and it's going to read everything up until it gets a new line statement. But of course, I'm going to need to declare this first. It's a buffered reader. And I'm also going to need to go get this library that's right here, as well as OS. So throw that in there, and then also OS like that. And then we'll just continue working here. I'm going to handle any errors that we might get. So I'm going to say if error is not equal to nil. Well, nil is returned if there is no error. So in this circumstance, that means there is an error, and we're going to log that. we now need to go and get log and throw it in here also. All right, so we got that value. Now we can go and get guess and trim any white space that might be on that. So trim space, and you're going to want to do this very often whenever you want to, you have input that has like new lines and things like that. That is why we're using it in this circumstance. And then just throw guess inside of here. Now I want to go and convert, everything is going to come in as a string, so I want to convert it into a integer. So I'm going to call this I guess. I'll just go and get rid of that. I guess, and again, handle any potential errors. String convert, and it's ATOI. String convert also needs to be added up here. So string convert. Very easy to remember which libraries are going to be used for which. So pass in guess inside of there. Now we can say if there is an error, again, not equal to nil, we're going to log that error. So fatal, like that, pass the error message. Then I'm going to say if I guess is greater than the random number that was generated, well, I'm going to print lower, and then I'm going to say else if I guess is less than the random number. I'm going to print higher, or maybe I should say pick a lower value to make that make more sense, and pick a higher value. All right. And then I can say else. If it's not higher or lower, that means they guessed it. So I'm going to say you guessed it. And exactly like that. And then at this point, we can call break to jump out of our loop. And I don't know if I use it later. I'll try to use it later. Another thing you can do is if there's a condition in which you want to stop executing code in the current loop and then jump back to the beginning of the loop, instead of break, you would use continue. What break's going to do is it's going to jump down here. And what continue would do is it would jump up here. So that's the difference between the two of those. And I think I got everything all right. Let's go and run it. And it says guess a number between 0 and 50. And we know that the number here in this circumstance is 19. So let's just bring this up here. And our random guess, let's say we do 25. Whoops, accidentally typed it over here. Let's get rid of that. And come down here, 25. Pick a lower value. Well, we know the value is 19, so that is indeed correct. And let's just play around a little bit longer, say something like 15. Pick a higher value, and then we pick 19. You guessed it. All right, our code works. And there's an example of how to use a for loop in a kind of example. Another thing we can do, let's just go and get rid of this altogether. It was kind of interesting. And I'm going to try to sprinkle in real projects as this tutorial continues. And they'll get more and more advanced as we go. Another thing you can do is you can cycle through an array with range. So I'm going to go and create an array. I know I haven't talked about arrays yet. They're just boxes that contain one specific type of data. And we just come in and how we declare them is like this. And I'll get more into the specifics of arrays here in as soon as I'm done with this. So I'm going to say that I want to go and create an array 1, 2, and 3. And I can say for. Well, in this circumstance, I am not interested in the index. So I'm just going to use that underscore there. And then I'm going to say I am interested in each individual value of our array. And then I just put our array name inside of there. And like that. And then I can go PL and num, and it's just going to cycle through the array and print out all the values. And range is pretty useful, and we'll be doing more and more things with it. You can see there we get 1, 2, 3. All right, so there are some basics with using for loops. More is coming, but now I want to talk about arrays. Now, an array is just a collection of values, like I said before, with the same data type. And what's most important is the value or the size of the array is not going to be allowed to change. The default values for an array, if you don't put something inside of them, are going to be 0 for integers and 0.0 for floats, false for booleans, And otherwise, normally you're just going to have an empty string like that. And let's go and just declare an integer array. So I'm going to call this array1, and I'm going to say that it has 5 spaces inside of it, and they are going to hold integers. There you go. You just declared an array. Now you can also assign values thereafter. You're allowed to change the values in an array. You're just not allowed to change the size of the array. And you can see that is allowing us to insert a value in the 0 index. You can also go in and declare as well as initialize at the same time. So we're going to say that this is going to have 5 spaces inside of it, int, and you don't actually need the 5 in that circumstance. 2, 3, 4, and 5. And there is going to be all of those different values. We can then go and get values by index. So I showed you how to assign them. So let's say we want the 0 index for array 2. That is how we're going to be able to get that. And let's just do a bunch of these. You can go and get our array length by array and length, but just by calling, see if you remember what it is. What's the command? len. And array 2, and what else? Let's say that we want to iterate through it. So I'm going to say I showed you how to iterate with a range before. I can go like this, and I less than length of the array, and follow that up by incrementing the array that we're working with. Now I want to keep it up here. This works better. Whoops, move that down. And so we go like this, and then I'll just go pl array 2 and I, and let's say we want to iterate with range, just so that you get to see this. So equal to range, and you just put array 2 inside of there, and it does all the work for you to make sure you don't go too far. And I'm going to say format dot printf. And what we're going to do here is we are going to output both the index and the actual value. Well, both of them are integers, so that makes that easy. And I and v. Another thing you can do is you can create multi-dimensional arrays. Let's call this array 3 equal to, and you have to define how big they are. So let's say this is 2 by 2, and it is an integer. And what I like to do is spread this across a couple lines. So we'll do 1 and 2 for the first, and then we will do 3 and 4 for the last, and you're going to have to end that with a semicolon. You have to remember that. Otherwise, the compiler will tell you about it. And let's say we want to print our multi-dimensional array. We can say for I equal to 0, and we're going to do this while I is less than 2, and then we'll increment that. And then after we do that inside of this loop, we're just go copy like that, paste it inside of here. Of course, this needs to have a new index variable name. So let's make it J. And then we can go and print all those different pieces of our array by going array 3 and I and J like that. And let's go and run this because we got a lot of stuff going on here. And you can see that we went through, we were able to find out what was at index 0. We got a length of 5. We cycled through all those. You can see here we have our index and the value. The only reason why they're on one line is because I didn't do a new line like that. So let's throw a new line in and run it again. And there you can see that we have both the index and the value. And then there's just the values that are printed out that for in the multi-dimensional array. What else would you like? Another thing, we could go and create a string and then get a slice of it. And we're going to talk about slices here as well. Also very important to understand. So I'm going to go a string 1 like this. And I'm going to throw A, B, C, D, E. That's good enough. I'm then going to go and convert this into a rune. So equal to, and an array of runes, I mean to say. A string 1. And then I can go and cycle. I don't care about my index, so I'm not going to put anything there. I just want my value out of this is equal to, and then you can use range here again, and with this rune array that we have. And then let's go and use our formatted print like we're used to. And I'm going to say rune array. And then I will go and throw our value inside of there. And like this. And then V at the end, like that. Let's go and do another one. Whoops, one thing I forgot. Let's go and put the array part in there. All right, good. And another one. Let's say we want to convert a byte array into a string. I don't think I covered that when I was doing casting, so I'm going to cover it right now. Equal to, and let's just create this, and byte. And this is how you create a byte array also. So you're going to see, as this, in having to try to cover absolutely everything there is to know about Go, it's sort of spread a little bit as to kind of use things in an interesting way and try to keep everything compartmentalized. Okay, so here is our byte string, and this is byte array. And I'll get into more specifics on slices and such. Just wanted to show you this briefly. And I'm going to go PL like that. And then I'll say I'm a string. And get rid of the extra semicolon there, like this. And B, str. And I'm going to cover slices like immediately after this. And you can see that we were able to get the code for all of these individual characters. All right? So I think we need to go and talk about slices. Now, basically, slices are like arrays, but they can grow. And they're going to have, to declare them, you're going to declare them kind of like var, like this. And then that's going to be followed up with a name and a data type. But you're normally going to be using make to make a slice. So I'm just going to go call this SL1 is equal to, and we're going to call make. And we're going to start off with a string. And we're going to say that it has a size of 6. Now, we can assign values by index. So let's do something like SL1 and 0 equal to, and just throw some random words inside of here. Okay, so we got that. We can go and get our overall size of our slice. So we'll say slice size. And what do you think we use to get the size? len. Remember that. It's very useful. Okay, we can go and cycle through these values with for. So I'm going to say for I equal to 0, I less than length of the slice, and then we want to increment it like that, and we can go and just print these out using our index right like that. We can also cycle using our range, so I'll say for underscore x equal to, and range SL1, and we can go PL and X for that. And what else would we like to do? Well, maybe we'll just run this so you can just see this. So we go like that and run it. And there we go. All right. What else? Well, a slice is basically going to point at an array. And what's interesting is you're then going to be able to create a slice of an array. So basically, a slice is a view of an underlying array. And you can have multiple slices on top of that that all point to the exact same array. So let's go and create this guy. So this is just an array. And it is going to have a size of 5. It's an integer. And I'm going to throw some values inside of here. Okay, so there is an array. Now what I want to do here with our slice is I want to start at the 0 index. And then I want to get up to, but not including the second index. So I'm going to say string array, and you start at 0 and up to, but not including the second index. You can also, sort of a shorthand thing you can do here, is you can say that you want to get, for example, the first 3 values. Well, you do not, let's put quotes around this, of course. So you do not have to put the 0 inside of there. What you can do instead is just go string array like that and put a colon and then 3. All right. And then we can also get a slice from a specific index to the end in a similar way. So let's say we want to get the last 3. We can go sArray and then put 2 inside of here and that. And just want you to know the only reason it's the last 3 is this is 0 index, 1 index, 2 index. So we're starting here and going the whole way to the end. Of course, if there was, 15 values inside of here, that wouldn't work. It would get way more than just the last 3, but whatever. I just want to make sure that's not confusing. Now, if you change the array, the slice is also going to change. So let's say we come in here and we say, well, actually, do I want to do that? Yeah, let's do this. So I'm going to say slice array 0 is going to be equal to 10. Well, if we then go PL, and then we'll go and get our slice array inside of here. Let's go and get some quotes around that. And then like this. Well, if we go and call for this to execute, let's do that. Let's come over here and let's run this. And you're going to see all those values, and you can also see the slice changed. So it's pointing at an underlying array. So if you do change it, it's going to change the array. It'll also change the slice. But what's even more interesting is changing the slice is also going to change the array. So you can say SL3 like this is equal to 1 to change it back. And then let's just go and copy this, and let's paste this inside of here. And then we'll say sArray like that. And let's go and see the changes our slice made to our array. And you're going to see that it changed it back. So see, it went back to the way that it was. What else? Let's say you would like to append a value. This is actually going to overwrite the array values if you append a value to a slice. So you can just say SL3 and call append, and we'll say SL3 and 12. And if we come in and then say PL and SL3, we go SL3, and let's just go and copy and paste this inside of here and run that, and we'll call this sArray and get the output for our array as well. And we run that, boom, you can see the results there, how we went and appended a 12 onto there and how it affected both of those. And also something that's important to understand is printing empty slices will return nils, which are just going to show as empty slices. So we can say SL4 and make and create this guy, put the string outside of here. So I'm going to say string, and then I'm going to say that I want 6 spaces, and I can say PL SL4 and follow that up with SL4, and also let's go and output by an index. So we'll say SL4 index like that, and this will be SL4 and index. And we can run that, and you can see the results that we get in those circumstances. See, it's empty, and here it shows nothing, but it's actually going to have a value of nil. All right, so there we go. We're getting into the meat of the Go language, and now I think is a great time to start exploring functions. Now, the basic format of a function is going to be func, whatever your function name is, the parameters, then return type if there is one. If there is no return type, nothing. And then you're going to have the body of your function inside of curly brackets. So we're going to start off simple and get more and more complex. So I'm going to create, remember, if you want this to be exported from your package, this would be uppercase, but we don't, so it's just going to be lowercase. And whenever I get into packages and modules and all that stuff later on and start using multiple files with Go, you're going to see what that's like, all right? So there we went and defined our function, and then to call it, we just say hello like that, and run it, and you can see we get hello back. All right, let's get more complicated. Let's say we want to return a sum of values. So let's just go and change this to get sum. Remember, camel case is used in Go. I'm going to go x and integer and y and integer. So I'm defining the type. And then I have to define what is going to come after what's going to be returned. And an integer is going to be returned. And then we can just say that we want to go return and x plus y. And then we can go and output this. So we can just do PL or something like that. And we can go and call getSum directly and then pass in 5 and 4. Works. And it's going to output just the result of that. And let me go and clear this so that we have more room over here for our output. And let's say that we would like to return multiple values. How do we do that? Well, we'll call this get2 instead. It's going to get one integer. And then if we need to return multiple different types, we're going to put the two types in parentheses and like that with a comma separating them. And then we could say something like return x plus 1, and we could go x plus 2, like that. And then we can go and call get2 and pass in a 5 in this circumstance and run that. And there you go. We got both of those values back. And we'd also be able to assign those values to separate variables if we would like to do that. Let's go. Let's try creating a function that is actually going to potentially trigger an error. I want to do a division, so I'm going to call this get quotient, like that, and it is going to receive a float, and it is going to receive another float, numerator and denominator for this division. And then inside of here, it's going to return two values. It's going to return an answer, which is going to be a float, and it is also going to return an error. So we have to handle all those. So what I'm protecting against is a division by 0. So I'm going to say if y is equal to 0, well, I want to define an error message that's going to be returned with a dummy value for the answer. So I'm going to say return 0, just a dummy value, and then I'm going to say format, and I want to trigger an error. So I'm going to say, here's our error, and the error message is going to be you can't divide by 0. It's a way of handling our errors, and there's plenty of other ways to handle errors, as you will see. And otherwise, if they didn't send a 0 for the denominator, I'm just going to return the value. And then, can you guess what this is going to be? Nil. All right, so that is the way that will work. So we'll say PL, and then we're going to call get quotient, and then we'll pass in 5 and 0, like that. See, there's no error. The compiler didn't catch it, so we have to catch it. But if we do this, you can't divide by 0 is what comes back. But if we then change this to 4 and run it again, you're going to see that it does work, and it also returns nil. And we also could catch that nil value whenever, if not equal to nil and all that stuff, like we've done in many examples. Another thing that's interesting is we can work with variadic functions. Big jargon term. What is a variadic function? It is just a function that is able to receive an unknown number of values. So what I want to do is I want to create a updated version of getSum. I'm going to call it getSum2. And I'm going to say that this is going to be an array of values. That's how it's treated. And then I'm going to put 1, 2, 3 like that, and int. And it's going to be able to receive an unknown number of values, and it's going to return an int. So I'm going to say sum is equal to 0. And then I am going to use range to cycle through these. So I'll get each individual num out of here and call range on nums like that. And I'll say sum plus equal to num. And then after this, return our sum. Exactly like that. Okay? Then down inside of here, what I can do is go and print this and call get sum2, and then pass in as many values as I would like. Doesn't matter how many, and it will work. And you can see 15 comes back as our answer. All right, so all kinds of cool things we can do with functions. Let's go and talk about how we can get an array passed into our function. And in this circumstance, we are going to use pass by value. So I'm going to say function get array sum, and it is going to get an array, and it is going to be an array of integers, and then it's going to return an integer value. And so again, I'm going to say sum is equal to 0. I guess I shouldn't have deleted that last function, but whatever. Underscore like this, value equal to range for our array that was passed in. And then I'm going to sum all of these together. And then I am going to return a sum like that. Then down inside of here, I'm going to go and create an array. So I'm going to call this VArray is equal to, and this is going to be an array of integers. And let's go 1, 2, 3, and 4. Works good. And then I can just go, let's get rid of this guy altogether. And I could do something like array sum and get array sum and pass in our array. And that will work really good. Let's run it. And you're going to see that we get our values back there. And this is pass by value. So any changes or anything we would do with the array in the function is not going to change the array outside of the function. Another thing it's interesting to know, let's get rid of this, is that Go is going to pass the value to functions, so it isn't going to be changed even if the same variable name is used in the function. So we can do something like f3 equal to, and we can get rid of this up here, get rid of that. So we can say f3 is equal to 5, and then we can print out f3 before function, like that, and show f3. And then we're going to create a function. It's going to be called change value. So change value and f3. And then we can say f3 after function. So after function, and we're going to see that nothing changed. But this is very important to understand that. And then after we do this, we'll get into pointers. Okay, so up here we say function change value, and it says f3. So it must be the f3, right? No, that has no bearing. This does not exist outside of the function, and it has nothing to do with that value right there. I will show you how to change them. Okay, so we'll say f3 plus equal to 1, and we could return f3 even. We can do anything we want. When we run this, you're going to see f3 before function, it's 5. f3 after function, still 5. So you did not change it even though the name f3 is right here. Now, if you do want to go in and change these values, what we're going to do is we're going to create a new, we're going to use something called pointers. So I'm going to call this change value to, and I'm going to change this just so we know we're dealing with pointers. I'm going to call this my pointer, and this is going to allow us to go in and actually access the place in memory. And I'll just go star like this to access that value and change it to 12 or something like that. And if we go and save that, then what we're going to be able to do is let's use F4 in this circumstance. So we'll change this to 10 like that. And then we will go and do basically exactly what we did before. So we'll change value 2 and change this to, that's fine. And let's go and run that. And the only thing we're going to need to do to make sure we pass as a reference, which means you'll actually be accessing the specific location in memory, is we use the address of operator, which is what it's called. And then you can see that we'll actually be able to change the value inside the function. Oh, and this is saying I'm not returning anything, so I can get rid of that. That's what that error means. And this is my pointer, not my string. All right, run it. And here you'll see that, yes, indeed, we changed the value from 10 to 12. So that's one way we can use pointers to make changes like that. We're also going to be able to store pointers. So let's go and create a new variable. Let's call this F4. And let's go, well, let's call it F4 just so that we know what's going on. We'll call it F4 pointer like that. And let's go and actually declare this. We'll go variable, and we need to use our star symbol here, which is in this circumstance going to signify that we are pointing to a integer. And then you go and get the pointer by using that reference operator and F4 like that. Except this is equals because this is the first time we're declaring this. And let's go and borrow this guy right here and throw it in right there and name this F4. Okay, now what we can do is we can say PL and F4 address like that. And we can go and get that address with F4 pointer right like that. And let's go and also say we want to go and get the value at that pointer. How you would do that, let's call this F4 value. And how you would get it by using the pointer to the location in memory is with our star symbol again. And there we go. We can also go and assign values with pointers. So we can go PTR is equal to 11. And let's go and copy this guy right here and paste it down inside of here. And this will be value once again, and we'll be able to get that. And another thing we're able to do is, well, let's just run this first. Well, we can go and show that these values are changed. So we'll just say F4 like that, F4 like that, F4 like that, just to demonstrate this passing of values. And then I'll show you how to pass arrays. And you can see how the values have changed. All right? So rundown of pointers in using just simple just values. And now what I want to do is talk about passing arrays using pointers. So let's get rid of this guy right here. Let's go and create an array and equal to, and let's say that it is 4 in length and integer and 1, 2, 3, and 4. And what I'd like to do is actually pass these values to our array, and then I want to double or multiply every one of these values by 2 and have it affect the outside world. So how do I do this? Or the world of the function main. So I'll go array values is what I'm going to call this function. And if I want to pass by reference so I can actually change the values in memory, I have to use that and reference right there. And I'm just going to print this out. So I'm going to say p array like that. And then up inside of here, we can go and get rid of this guy altogether. And we can go function double array values and array. And we're going to use our star symbol here again. We're going to say how big the array is that we are going to be referencing. And then I can say 4x equal to 0, semicolon, x less than 4, and then x plus plus like that. And go and get each of those individual values inside of our array and multiply those times 2. And that will affect those values outside. So, and I don't need to say, I can just save this like that and run it. And you're going to see that all those went, and what's it say? Expected, I'm not sure what that error is in reference to. I don't know. Run it again. And there you can see we doubled all those values in the array outside of the function by using pointers. Another thing that's interesting is, let's say we wanted to pass a slice into a function. Well, what's interesting is passing a slice to a function works just like when we were using Varadic functions. So let's go and create a slice here, equal to, and I go like this, and float 64, and I'm going to throw inside. What I want to do is I want to create a function that's going to get the average of these values. So we can grab that guy, and I'm going to use formatted printing here. So I'm going to say printf, and like I said, I want to get the average, and let's do percent, maybe 3 decimal places, and it's going to be a float and then a new line. And then I'll go and call get average. And what you do here is you go I slice like that, followed with those 3 dots like that. And now I need to come up here and go and create get average. So let's just go and get rid of our function right here. And then up inside of here, say function get average and nums dot 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 and float 64. See, just like a variadic function. And then it's going to return a float and var sum float 64 equal to 0.0 and variable, and I'm going to have num size float 64 is equal to float. I want to do a cast, so I'm going to say 64. I'm casting from an integer into a float. I'm doing my best to keep covering things over and over again, so this is a real learning experience instead of me just typing everything. So I'm going to say 4, and I'm going to cycle through this. Value equal to, let's use range on all those numbers passed inside of it. And we'll say sum plus equal to all of those values. And then after I get those sums, I can go sum divided by number size. Exactly like that. Change this into lowercase. Save it and run it. And if we do, we get our average is 13.667. All right, so there you go. A couple examples using functions and floats and pointers, and more are going to be coming. There's a whole lot we can do with Go using functions, but now I want to talk about file I/O. All right, so we're going to be able to create, write, and read from files. So let's just go and create a file. I'll just call it F, and then we're going to go os dot and create, and then we just give it some name. It doesn't matter what it is. And then we're going to say if, again, we want to handle these errors, not equal to nil, then we're going to know that an error occurred. And we can come in here and throw in both OS as well as log. Whoops, make sure you put it in quotes like that. Okay. Now, another thing we want to do is anytime we open a file, of course, we want to close the file. So what we can do is we can say defer f.close. And what this will do is as long as we are in the main function, the file will be open. And then as soon as we leave the main function, it will close. Basically, what is determining when the file closes is this closing curly bracket. So whenever we're out of scope, it closes. Now what I want to do is I want to create a list of prime numbers, or an array of prime numbers. And again, this is going to be integers like that. And then I'm just going to go 2, 3, 5, 7, and 11. And I want to create a string array from an int array. And how we can do that, I'm going to go s prime array and string, and I will say 4 and I. This is another example of where I'm teaching numerous different topics, and I'll do my best to label them in the table of contents, but that's why it's better to watch the whole entire video if possible, because that's the only way to learn everything. Okay, so I'm going to say prime array, and then I'm going to go string convert dot itoa and I. And string convert needs to be put up here. So string convert. And then we have our closing bracket right here. And now what I want to do is I want to cycle through the strings and write them to a file. So I'll say 4, like that, and num equal to range s prime array. And then, of course, anytime we potentially write, there is a chance of an error, so we'll say this, and then we'll go f dot write string, and I'm going to pass in each of the numbers followed with a new line. So that's how everything is going to be divided up. And then, of course, after this, let's say that we want to catch any potential errors. So I'm going to say if error not equal to nil, I'll go log dot fatal error. And then what we'll do is we will go and open our created file. So I'll say file error equal to os dot open, and we called it data dot text. And if error not equal to nil, then log as fatal. And after that, we could then go defer. We don't really have to do this, but I'm going to do this. So I'll say defer close. And it's actually better to just have this be at the end, but whatever, this is fine. And now what I'm going to do is I'm going to read from the file and print out all the lines one by one. Let's call this scan1 equal to, and everything is going to be buffered, new scanner, F, and we need buff.io up inside of here. So buff.io, and then we will go for scan1 dot scan, and just print these out and maybe put prime in front of them. So I'll say prime and scan1 dot text, and that's all we're going to do for that for loop. And then of course we have to go if error equal to scan1 dot error, and then just to mix things up, let's do this all on one line. So I'll say error not equal to nil and log dot fatal. So I'm just trying to redo things in different ways so that we can see all this. So after we did all of that, I don't think I have any errors. Let's go and run it. And you can see there are the prime values. If you come over here, you're also going to see that data.text is right here. See, we can open it. There it is. So we were able to properly open a file, create a file, write to the file, and then read from the file, all at exactly the same time. Now what I want to do is I want to go and actually check if a file, or I want to append a file. All right, so let's go and let's get rid of all of this stuff, or maybe we'll just comment it out just to get rid of it. Okay, so it's very important whenever we are appending that we are going to be able to have to set certain settings here depending that are going to determine exactly how we're going to work with a file. Now you're only going to have one of these options. So this one here is going to deal with open the file for read only. This is going to be write only, and this is going to be read or write. See, it wouldn't make sense to open it for read and write and read only, or write only and read. Okay, so that you're going to define that one time, and then you're going to define other different settings in regards to how we're going to go and append this information. It probably makes more sense to just go and do it. Okay, so what I'm going to do is I'm going to first check if my file exists. So let's go like this, equal to os dot stat, and does data text exist? We know it exists, but of course we're checking. All right, then we're going to say errors is, and this is another thing we can do in regards to doing some error handling directly right here. So I'm going to say is the error os.err not exist. And in this situation, we're catching a very specific error. Okay, so we're go up here. Oh no, that's fine. Okay, so that's what we got going on there. Then what we're going to do is we're going to say PL and print out a specific message. It's going to be file doesn't exist. So this is more me actually using error handling in a real scenario, which would be working with files. But you would use this in all circumstances. This isn't something that's just specific to working with opening files. This is how we can handle different errors in other situations. So we'll say error, and we want to keep OS as well. So I'm just not going to save that because it's going to disappear otherwise. All right, so file doesn't exist. Else, Well, there could be some other situation that could come up, but what we want to do is we want to come in here and we want to open our file, since it does exist. So we'll say equal to os dot open file, and the file, since we know it exists, data.txt, we're going to plug that inside of there. And then we're going to define our settings for how we want to work with this. So we want to work with it, like this, append. We want to say that we want to append data, or, and this is how we are able to stack all these different settings. We'll say create, or os, you can put those together or have them separate, doesn't matter. os dot o, and this is going to be read and write only in this circumstance. And then we can throw in our permissions in regards to who can access the file thereafter. What else can we do? Well, of course, we want to go in here and check for any type of errors that may have come upon us. So we'll say if error not equal to nil, that's fine. Then we will say log dot fatal and pass our error inside of there. And we're getting this error up inside of here. We just put a colon inside of there. Boom, it goes away. And put a colon here. You need to put that colon equals anytime you are assigning to something that has not previously existed. So those errors should go away now. And now it's just saying that it's declared but not used. Perfectly fine. All right, so we got that there. We're going to catch that error right there. What else do we want to do? Well, we want to defer closing. So f dot close, because remember that is no longer inside of here. And then let's go in and let's write the next prime to the file. So, and this is going to append to the end. So we'll do error, and we'll do this on same line again, just to, you know, get you more acquainted with working and handling errors in the multiple different ways we can deal with them. So we'll say 13 and new line like that. And then we'll say error not equal to nil, like that, and log dot fatal error. All right. And if we didn't make any errors, we should be able to go in there and append that information. And if we come over here and open up data.txt, yes, indeed, we see 13 there. All right. So that is how to create and work with files in numerous different ways. We're also going to be able to pass values to our program from the command line, but what I'm going to do here is I'm actually going to create a new file. So let's go like this, and let's give it a name like cltest.go. Create that guy. And what we're going to do here is I'm going to go package main. More on packages later, where we use different package names. It's impossible to do everything at once. So what I'm going to do here, and by command line I mean here in our terminal, we're going to be able to pass values inside of it, and it's going to do different things with those values. So what I want to do is I'm going to need format, and I'm going to need OS, and I'm also going to need string conversion, I believe. So here's those examples. And again, it's going to have main inside of it. So here is main. This is where everything executes. And what I'm going to do is I'm going to go format dot print line and os dot args. And let's do a couple different things here. I'm going to get all the values after the first index, because what's going to happen is if we do this, well, why don't I can just build it. So I just need to go inside of here, and then I need to go build cltest.go, like that. And there it's been built. And let's move this over here just so you can see it a little bit better. And then I will just simply go dot /. Now, if you are on a Mac or Linux machine, you're not going to do that. You're just going to type in the name of it, but we're just going to do this. So let's say we'll CLS, clear this up. Okay, so now I'm going to go dot / CLTest. And remember, if you're on Windows or Mac, you're going to just go and type CLTest. And then I'll just pass some values inside here. So 24, 43, 12, 9, 10, whatever, and run it. And you can see what it does is it returns an array. And the very first item inside of the array is actually the app itself, the executable. and then you have all the values here. So if you want all those values, all you need to do is get rid of the app part and then continue on from that point. And so what I will do is do that. So let's say we want to get all the values after the first index. Let's just call this args like this, and os dot args. And I don't know if you remember, that's our way of getting a slice from the beginning until the start from the first index to the very end. We don't want the first index, we just want that. Now what I want to do is create an int array from this string array. So I'll say var I args is equal to, let's move this over so we have more room for our important code so that we can read it. So I'll go like this, and then I'm going to go and define this as an integer. And then, whoops, don't forget to put your curly brackets in here at the end and tab that in. Then I'm going to say for underscore, we don't care about that, so we'll say I colon equal to and range args. And then we're going to say we want a value, and we also are going to deal with the potential error. So we'll say string convert dot atoi, and that's ASCII to integer. And we'll say if error not equal to nil, like that. And another thing we can do is we can panic. We can call panic, and that's another way to trigger an error. String conversion needs to be inside of here, so string conversion. There it goes. All right, so there's another way to trigger an error. I args is equal to, and we'll say append I args value, and that's pretty good. And what else can we do here? Let's say that we want to go and get the maximum value from the values passed inside of here. Sounds like something somewhat useful to do. So I'm going to go max is equal to, whoops, max. There's max is equal to, and I'll make it 0 by default. And then I'm going to cycle through all the values that were passed into our array, or passed into our command line, and output the maximum that was passed. So I'll say range I args like that, and if val is greater than max, max starts at 0, then max becomes the new value. And then after it does that for all of these guys, I'm finally going to go format dot print line and max value. And if you're wondering why all of a sudden I'm typing print line, well, the reason is that I didn't do the alias for print line. That's the reason why. And we can come in here and run that. Or no, we can't run it. It's command line. Duh. Okay, so just come over here. I'm going to press up. Where is... There it is. Go build like that. And then where we passed in those values. And you can see the maximum value passed in was 43. Okay? So some stuff you can do with command lines. And of course you can use a lot of what we've covered previously in the video to play around more with the command lines. But I think that is a good overview of what we want to do. And now what I want to do is get into packages and get more into traditional Go programming. Now packages, and we're also going to talk about modules. Packages are going to allow you to keep related code together. And why this is important is Go looks for package codes in specific directories. Now, one thing to be aware of is if you're using Visual Studio Code like I am and you're going to have multiple modules, you're going to get an error. So what I want you to do is to go to File and Preferences and Settings. And then inside of here, you want to search and search for GOPLS. And there it is. We can come in here and click on Edit in Settings.json. And whenever you do this, what you're going to want to do is make sure that GOPLS, this is not going to have anything inside of it. It's just going to be 2 curly brackets with nothing. You just want to copy and paste experimental workspace module and mark that as true. If you don't, you're going to get a weird error that talks about multiple different modules and things like that. Okay, so just go and copy and paste this into the settings.json file exactly how I told you to get it, and that error is going to go away. I'm just going to say don't save because I don't even know what it was doing. All right, I don't think I changed anything. Okay, so make sure you do that. Now what we want to do is we're going to be working with different files and different directories and so forth. So what I want to do is I'm going to be doing a lot of different things over here inside of my terminal, and I'm going to do some stuff over here. Okay, so what I want to do inside of here is I want to make a new directory, and just to keep it simple, I'm going to call it app. Okay, so here is our new app directory. And then what I want to do is I need to generate a, or I need to choose a module path. So, and to do that, I need to create a go.mod file, or module file. So I'm going to come over here, and I'm going to say change directory to app. And now I'm in the app directory. And I'm just going to type in go mod init. And I'm going to type example project. You can call this whatever you'd like. So example project. And let's move this out here so you can see this all on one line. So example project. And then just hit enter like that, creating a new go mod module called example project. Okay, so we can move that over there. And then what I need to do is, well, basically, Go modules are going to allow you to manage libraries. And they contain one project or library and a collection of Go packages. And the go.mod file, let's open this up. Here's go.mod. There it is going to contain the name of the module and versions of other modules your module depends on, if they do, and as well it's going to have the version of Go used whenever everything worked perfectly fine here. Now what I need to do is I'm going to go into the app and I'm going to click on this and create a new file, and I need to make a new main.go file. So there that is. Just make sure it's at the same level as your go.mod file. And you're going to be able to have many packages and sub-packages. And what I want to do is I want to create another new directory inside of app. So I'm going to go app like this, and I'm going to call this my package and enter. And then I need to make another file inside of my package now. So I'm going to click on this, and I'm going to call this my package.go. And make sure your package names are all lowercase. And then again, anything functions-wise that you have inside of these packages that are uppercase are going to be accessible outside of there. So what I'm going to do inside of my package.go is I am going to create a function that is going to convert int arrays into string arrays. So I'm going to go package like this, and let's just call this stuff and import. And I need to import different libraries I'm going to use. I'm going to use errors, and I am going to use string conversion, and I am going to use time, I think. I don't know. Let's see. All right, so let's go like that. And then I am going to also create var name string. See how that's uppercase? That means it's going to be available outside of the package. So I'll say Derek. So we'll also use that. I'll show you how to run functions and then also access variables. So I'm going to create a new function, and uppercase, now it's accessible outside of the package, to string array. And it's going to convert an integer array into a string array. That's something that we've been having to do multiple times, and anytime you do something multiple times, it makes a lot of sense to go and create a package that handles it for you with your, so it can be reused instead of retyping code over and over again. So I want a string array that it's going to return, and pass that there. So I'm going to say var string array, and define this as a string array. And then we will just simply say for underscore, don't care about that. And then we'll say like this, range, and then we'll cycle through our int array and go string array is equal to append and string array and string convert dot, and this is going to be integer to ASCII, or string in this circumstance. And then after we cycle through all those, our function is going to return string array, exactly like that. All right, now that we have that set up, we can go over into main and actually use it. So we'll say package main, and then we need to import some stuff like this, and I'm not sure what we're going to get. So I'm going to say function main. Anytime the package is main, that means it has to have a main function inside of it. And I'm going to say format dot print line, and I'll say hello, and I want to get the file out of here. So I'm going to say I want to get this, my name, out of here. So one thing I'm definitely going to have to format is, I'm going to go like this, and of course I need format, but I'm also going to need a reference to that package. And what did I call it? Well, I called it stuff. So I'm going to come in here, and I'm going to go stuff like that. Whoops, get rid of this. I'm going to say stuff like that. But what I'm actually going to be referencing is example, which is our module, and project, and my package, like that. And whoops, don't do that. All right, make sure. There we are. Okay, so we got stuff, my package. Now what I can do is say hello like this, and then say stuff and reference that name right like that. And if I go inside of here and run it, you're going to see it says hello Derek. And it got that out of my package that I have right here. See, there's my name. So now what I can do is then go in and do the string conversion. And I can use those functions as well. So I'm going to say equal to, and this is a fantastic way to organize all of your code. And normally when you write a Go program, this is what you do. Well, let's stick with what we did before and work with our prime numbers. All right. So then I'm going to have a string array equal to, and to call that function, you just go stuff like that, and then you're going to say int array to string array, and pass in our int array to verify that I actually did this the right way. And I have multiple parentheses, don't need those, so let's go and get rid of that. And then I'm going to go and print this out. So I'll print line, and I'll pro string array like that. And then just to prove that it is what it is, I'm going to go like this, copy this guy right here, bounce down here, and then I'll call reflect on it. So reflect and type of and string array. And we're going to get into testing and things like that later also. So I'm going to go here and reflect like that. And let's go and test it to see if it worked. And indeed, it converted it into a string array. All right. So there you go. That is some meat on working with packages as well as modules and a whole bunch of other stuff. And I'm going to be doing a lot more with packages and modules and all those things later on. But I am now going to talk about maps. Now, basically a map, and I'm in Hello Go again. Maps are basically collections of key value pairs. And keys can be any data type that can be compared using equals to. So if you can use equals to use it, then you can use that thing as a key. And another thing that's important is the key can be a completely different data type than the value. And the basic layout of declaring a map is you're going to type var, whatever your map name is, followed with the keyword map. And then you're going to type inside of curly brackets whatever your key type is, and then outside of it whatever your value type is. All right, so that's the basic. Let me just give you an example. So let's declare a map variable. So I'm going to call this heroes and map like that. And I'm going to say that the key is going to be a string. It can be any data type. Like I said, as long as equals works. And then we'll go and actually create a map. There's multiple ways of doing this. This is actually not the way you normally do it. Next, I'll show you the other way to do it. Like I said, I want this tutorial to be literally everything about Go you could more than likely see. Okay? So that's one way to do it. You can also do it in one fell sweep. So we're going to just go villains, maybe? Villains, and equal to make and map. The string is going to be the key, and string is also going to be the value. Now, we can come in here now, and we can add keys and values. Let's move this up here just to keep our screen real estate nice and tidy. All right, so we can come in and go heroes like that, and assign our key, which is going to be, in this circumstance, Batman. And we can say that we want to assign the value is going to be Bruce Wayne, like that. And let's go and do a couple more. So copy this and paste that, paste that. Okay, so the next one's going to be Superman. Superman, and this is going to be Clark Kent, and lowercase k, there we are. And then we're going to have the Flash. And the Flash is having some issues in the real world right now. Okay, so throw that inside of there. Barry Allen. And that's the comic book Flash. Okay, so let's go and also do the similar stuff for villains. So the villains are not quite as good at naming themselves. Lex Luthor's secret identity is going to be Lex Luthor. Alright, he needs to get better at naming himself. Okay, so there's Lex Luthor. And you can also define with a map literal. So let's say Super Pets. Didn't see the movie. And we can say map, and I'll use a different key. I'll use an int here for this, and string. And then we can have our key be 1, and then Crypto, I think is his name. So there's Crypto, and then Batman's dog. I don't even know if this is real. Well, I guess it is if it's in a movie. Bat Hound. All right, I think that's right. And what else? We can also go and get a value with a key. So we're going to say format. Let's use printf here in this circumstance. So printf like that. And we'll say Batman is, and I'm going to have it determine what the data type is in this circumstance. And then heroes. That's what V does. And Batman. Whoops. Batman like that. And what else? Let's move this out of here because I'm not doing anything else with it. Let's say that, well, another thing you can do is if you access a key that doesn't exist, you're going to get a nil character passed back to you. And also this got out of the way, so let's move that over here. So let's say we went and said something like Chip. We want to know about Chip, Super Pet, and Super Pets, and 3. See, it doesn't exist. And you're going to see you get a nil character returned. You can also check if there is a value or nil. So you could say something like OK equal to, and Super Pets, and let's use 3. And we'll say PL, is there a third pet? I don't know. Let's throw that there. Whoops. Like this. And get this quote and put it where it is. So equal like that. And then we'll throw OK in there. It's either going to, it's going to be a Boolean, give you something, information. Another thing you can do is you can cycle through a map. So let's say I want to say 4K, I want the key and the value. And if you don't want the key, you could just put undefined like that. But in this circumstance, we want it. And the same thing with value. If you only want the keys but not the values, well, that's how you do that. And equal to, let's use range again, because I don't really like using 4 unless I have to. And let's go and use printf again. So printf, and I will say I want to use a string in this circumstance is, and I'm going to out all of my superheroes here. So like that, and by out I mean I'm going to list their name. And there's all that. And we can run this and see what happens. And you can see right here, is there a third pet? Comes back as false. Chip, this is actually a nil character. And you can see I listed all my superheroes. And I guess the last thing that you might want to do is maybe Warner Brothers doesn't want the Flash to exist anymore, and so you just delete it by just coming in and referencing the Flash's key, and then boom, it's gone. Okay, so there you go. There's a rundown of maps. Probably do a little bit more with maps as the video continues, but now I want to talk about generics. This is kind of interesting. Whenever I was doing some research, because I want to make sure that absolutely every single thing I do is up to date when I make tutorials, I go and do a lot of research. I went on to a prominent education site, and they said Go is the perfect language, except it doesn't have generics. What actually, Go does have generics, and I'm going to show you that right now. But basically, with generics, we can specify the data type to be used at a later time. And this is extremely useful. I'm going to give you a brief example here. It's mainly used when we want to create functions that can work with multiple different data types. So what I'm going to do is I'm going to go and actually create that. So let's just come up here in our function area where I'm going to make this. And what I would need to do here, well, some things you need to know, is the generic type parameter is going to be capitalized. And you're also going to put it between square brackets. One other thing that I want to do here, though, is I want to define what our generic can potentially be. And I'm going to do this by defining a type. And I'm going to say that I'm going to limit this is a constraint using an interface. I'm going to talk about interfaces later. Just understand that what I'm doing right here is I'm defining my constraint being that my generic is only going to be allowed to be an integer or a float, and that is it. All right, so my function is going to work as long as the generics that I receive are either integers or floats. Now, you can use a couple different constraints. Like, for example, if you would use any, then that would literally match anything. You very rarely use it. You could also have a constraint be comparable. That is very often commonly used. And what I mean by is if I say, well, let's come in here and actually create a function. So I'm going to go function, and this is going to go and get some, and I'll call it gen, just to define that it's a generic. Okay, so what you're going to do is you're going to have your generic. It's going to be uppercase, like I said before. It's going to be in square brackets, like I said before. And then you're going to have your constraint. So it's going to limit what that generic can possibly be. You can also do comparable, you can do any, but what I'm using is a custom constraint. And I'm saying as long as it is some type of int or float, I want this to work. So I'm going to use my constraint. So that I find very useful. So let's go and paste that inside of there. And there's a whole bunch of other constraints that are actually built into Go. I'm covering almost every single thing you can do with Go. I'm not going to go through every single constraint. If you want that, this is where you go. Package, Go, Dev, Golang, and look specifically for constraints, okay? And that will be on GitHub for free. You can go and search for constraints to your heart's content. Okay, so there's a whole bunch of customized ones. I'm just using this one. Okay, so then what you do is you have your variable, and then you follow it with your generic, which is going to be t. Just like imagine this is an integer, and I have int here. Well, now it's going to be an integer or a float, because I defined that in my interface that I have up inside of here, but that's it. So make sure that this is a t also. And basically what this is saying is we are going to receive either integers or floats. We want to be able to work with them, and we're going to go and return the same data type. Good. So let's go return and x plus y, right like that. So that's going to give us that. All right, so now that we have that, let's go and use it inside of our main function. So what we're going to be able to do is work with integers or floats. So we'll say 5 plus 4 is equal to, and go get some gen, like that, 5 and 4. And so we're working with integers, but I'm also going to be able to work with floats. So let's just change this to 5.6 and 4.7. We'll do more with generics as we continue here, but I would love to just keep everything as simple as humanly possible. All right, and we got that, and we run it, and you're going to see it works with integers or floats. All right, and one thing that is important is, let's say we have this right here, but we put it inside of we actually try to pass a string. Guess what? It gives us an error right here. String does not implement my constraint, and we can't do it. Okay? So it's going to block us from doing that. And I think that is very useful. All right, I think that's good stuff right there. And now what I'd like to do is talk a little bit about structs. All right, so basically structs are going to allow you to store values with many different data types in a very structured way. So what I want to do is I'm going to create a struct called customer. So I'm going to say customer and struct. And there it is. And then I'm going to define what the values are inside of it are going to be. So I'm going to have a name, which is going to be a string, an address, which is going to be a string, and I'm going to throw balance inside of here, which is going to be a float. Just to show you, see, you can have multiple different data types all inside of there at the same time. Now down inside of main, what I want to do is create a customer. I'm going to call it TS, customer, like that. And I'm going to start adding some values. So I'm going to say TS dot, sorry about my naming of variables. I'm mainly doing it so that it is very easy to have this in a great big giant long list and you can compile absolutely everything and there's no conflicts. That is the major reason why I pick the variable names that I pick. Okay. So all I'm doing is, well, don't worry about it. Okay, so I'm going to go and add some values to this specific struct. So I have Tom Smith and he lives at 5 Main Street. And TS dot balance is equal to, let's say Tom Smith owes us $234.56. All right, so that's good stuff. Let's go and create some more functions. Okay, so these functions are going to be specifically associated with our struct. So I'm going to come in and I'm going to say function get, whoops, customer info and see customer. So customer, make sure this is uppercase if your customer is uppercase. And then I'm going to do some format printing. Let's go like this. And I want to do printf in this circumstance. I'm going to say how much money that our customer here owes us. So I'm going to go like this, owes us, and 0.2, so I only get 2 decimal places, and a new line. And then to reference values inside of our struct, you just do C in this circumstance, and then balance. Let's go and create another function here. I'd like to also be able to add a new customer. So I'm going to say function, new customer, add, pass in that customer, and we're working with pointers again. And address is going to be a string. And there we are. And I'll just say c.address is equal to address. And do I want to do anything else with it? Not really. I think that's good. All right, so we got those, and let's come back here and let's go get customer info and pass in our customer. And then I would like to also go new customer add, and I'm going to use a reference so that I'll be able to change my customer. Let's go using our reference operator like this, and we'll say that our customer now lives at South Street. And we can then come in and go PO and address like this, and just to verify that the address was changed globally or in memory or however you want to refer to it. And then let's go and also create another customer. I'm going to go and say this customer is named Sally Smith. So I'm just going to do S, uppercase S, is going to be equal to, and to go customer, just to show you that this is what's called a struct literal. And you can go and define the struct and give it values all at the same time. And you're just going to put them in the same order that they are listed inside of our struct. So customer, and we're going to put this inside of curly brackets like that. So I'll have Sally Smith, and I'll have 1, 2, 3 main, and I'll say that Sally Smith is good. She has all of her bills paid for us. And let's go and reference this to say name like that, and go and get Sally Smith's name out of here. So name. And then I think that is good. Let's go and run this. And you can see Tom Smith owes us $234.56. You can see that we changed Tom Smith's address, and that is how we get Sally Smith's information. Okay, structs are more complicated. Let's go and maybe let's work with something like a rectangle or something like that. So let's get rid of all this. There it is, it's gone. And let's get rid of all of this. So we're going to create a brand new struct. I'm just deleting it all. And come up in here. Okay, so let's go type and rectangle struct like that. And we're going to define that there is a length and a height. You can define variables this way also. Float 64. So it has two variables associated with it, and they're both going to be floats. Let's go and create some functions associated with this. So this is going to be our rectangle. Do I want this rectangle? Rectangle. So rectangle. And this is specifically assigned to this struct. It doesn't just work with a struct. It is a function that is part of the struct. So let's go like that. And it is called area. And it is going to receive or output or return a float. And we're going to say return r dot length times r dot height. So there is that. Anything else I would like to do? I think that's pretty good. So let's just do that. And then we'll come down inside of here and create a new rectangle struct. Let's just call it rect1 and equal to rectangle. And we'll throw 10 and 15 inside of there. And then we can go PL and rectangle area like that. And just go rect1 dot area. And it's going to automatically work for us. Why is that wrong? Oh, I know why it's wrong. These are curly brackets. So we'll just go curly bracket and curly bracket. And guess what? Problem goes away. Let's run that. And you're going to see we're able to calculate the area. Let's keep on doing some other stuff. One thing it's important to understand is that Go doesn't support inheritance, but it does support composition. And how you get this is by embedding a struct inside of another struct. So let me see here. How do I want to demonstrate this? I think well, let's just get rid of this first off. And let's get rid of this also. All right, so what I'm going to do is I'm going to go and define a contact. So I'll say type contact struct, and this is going to have a first name, which is going to be a string, and a last name, and that is going to also be a string. And let's make these camel case, right like that. And I'll say phone and string. And then on top of that, I'm going to create another one like this. And these are defined types, which I'm actually going to cover next. It's just, it's hard to cover stuff without, you'll see what type means here in a minute. I'm also going to define a business, and the business is going to have a name, and also it's going to have an address, but also it's going to have a contact person that we're going to be able to get in contact with if we want the business. All right, so that is how that's going to be set up. And then let's also associate a function with the business struct. So how you do that, func and b and business. This is the struct that this is tied to. And let's say we want to get some information on the business or something. So we could say format dot printf like that. And we could say contact at, and this will be the business name, is, and then we're going to have the contact's name, and that's the first name, and then this will be the last name. Then how we can get it just go b dot name like that, and b dot contact. You have to reference the whole thing. Let's put this on a separate line here. So we'll say contact, and then dot L, or no, it's going to be first name, and then finally b dot contact dot last name. All right, and that's going to do all of that for us. And then we can come into main, and let's go and create a new contact and a new business, and then call this guy on it to print it all out. So let's just go contact 1 like this, and contact like that, and then we're just going to list James. Oh, let's give him an uppercase name. So we'll say James, and Wang is going to be at 555-1212. And let's go and do the same for business. So I'll just call this business 1 equal to business, and we'll say that he is at ABC Plumbing, and he lives at the business is at 234 North Street, and our contact is going to be contact 1 like that. And there we are. And now what we can do is just simply go business 1 and reference the business info. And if we run it, it's going to print out a, did it get it right? Uh-oh, there's an error on line 34. Unexpected new 34. Oh, let's throw this right here. That comma, something I do all the time. Let's run that. Oops, and the same problem right here. So let's go like that and run it, and boom. Contact at ABC Plumbing is James Wang. All right. So there you go. Overview of structs. Of course, we are most definitely going to do more with structs, but now I'd like to talk about defined types. All right. So we used a defined type previously with structs. And what's interesting is you can use them also to enhance the quality of other data types, which we did a bit there. And what I want to do here is I want to create a whole bunch of different types of measurements. So I'm going to come up inside of here, and I'm going to say type teaspoon float 64, and I'm going to say type tablespoon. If you don't know what these are just ways of measuring that are used in the United States. And I'm also going to say, and the whole point of this is I'm going to convert these to milliliters. All right, so that's where this is coming in. So these are different cooking measurement types that we can use for conversions. So what are we going to do? Well, we're going to start off doing like this. Okay, so we're going to proceed to get better. So we're going to say we want teaspoon to milliliter. Like this is the first way that we're going to try to work with this. So we're going to say teaspoon, and it's going to return a milliliter. Then we can just come in and say return milliliter is whatever the teaspoon is times 4.92. And then we want to also do something similar for our tablespoons. So we're going to say tablespoon to milliliter. So tablespoon, or tablespoon to milliliter. And this is going to be passed tablespoons. It's going to return a milliliter, and in this situation, this is going to be 14.79. These aren't exact, they're close enough. All right, so let's go and get those. And then what we want to do is inside of main, I'm going to say ML1 colon equal to, and I'm going to define this as a milliliter, which is going to be teaspoon 3 and times 4.92. Okay, so I'm going to do this on its own. And let's go copy this. Well, first off, let's go format dot printf, and 3 teaspoons is equal to, and this is going to be 0.2f milliliters, and throw a new line inside of there, and then get milliliters 1. So I'm doing this in multiple different ways. All right, so we're going to do this directly right here, and then we're going to use functions, and then we're going to enhance and improve our functions. So 2 like this, and we'll do tablespoons, so that's TBS, and let that be 3, and 1479 like that. And then change this to 3 tablespoons, so tablespoons is equal to milliliters, and then change this to ml2. All right, so we're going to do this and save that and run it. Okay, so boom, boom, boom. There we went and got what we were looking for. Another thing that's interesting is we can actually go and use arithmetic and comparison operators on these. So let's say we do something like PO and 2 teaspoons plus 4 teaspoons is equal to, and teaspoons is going to be 2, and teaspoons is going to be 4. Do that, and we could do, copy this, paste this down here. We could also go teaspoons, and is it greater than, like that. And then over here, just change this to greater than, and see what we get. And then I'm going to use these guys up here to convert with functions. And then this, which is actually the bad way to do these type conversions. I'm gonna show you the bad way, and then I'm gonna show you the really great way also. So I'm gonna say format dot and p, and let's use printf, and I'll say 3 teaspoons is equal to, and go and get these. So, and if you're wondering why I'm showing you the bad way, I just want to show you. Like, this is the traditional. I guess I shouldn't say bad way. What I should say is this is the traditional way that somebody that wasn't aware of what you could do with Go might use to solve this type of problem. All right, so we would say something like teaspoon to milliliter and pass in 3. And then let's go. We went and made the function. We might as well use it. Let's do the same thing for tablespoons. So this is all the same, and the only thing that changes is this part. So tablespoon to milliliter. Is that what it's called? Tablespoon to... Oh, I see what I did. This is going to be tablespoon like this. So TB to mill, and this is teaspoon to mill. I don't know why I made that uppercase and that. Oh, I know why, but you know, whatever. Okay, so let's run that, and you can see, hey, you know, we were able to do our comparisons. And also, we were able to go and get the right calculations. But there's a better way. All right, so what we can also do here is we can use what is called an associate method with these two types. And this is the way you want to do it. All right, you don't want to do it this way. You want to do it this way. Okay, so this is the way to do it. So as you say function, and you're going to say that we're working with teaspoon types here. And I'm going to call this 2 milliliters, like that. And then we're going to return a milliliter. And then you can say inside of here, return milliliter. And that's going to be teaspoon, whatever that is, times 4.92. And this is when we're getting into the beginnings of doing kind of cool stuff. All right, so I'm going to then have this be tablespoons, and then have this be tablespoons. So there's tablespoons, 2 mil, and everything works fine. And what we're going to do down here is this is going to be TBS, tablespoons, times 14.79. Let's get rid of this, say 14.79, like that, and save it. And then what we can do is come over here, and this is really cool. I'm just going to get rid of this stuff here. So get rid of that, and maybe we want to also, yeah, let's just get rid of all of it. So it's all gone. All right. And what I'm going to do is say format dot printf like this. And inside of here, I can quite simply just say 3 teaspoons is equal to this 0.2 F milliliters like that. And then to do our conversion, I just say teaspoon to milliliter like that, and 3. And then I can just come in here and, well, let's change this, actually. And now I can come down inside of main and say something like teaspoon 1 is equal to teaspoon and give it 3 teaspoons as an option, and then say like this, and print F like that, and 0.2 teaspoons is equal to 0.2 milliliters \n, and then do our conversion very easily by saying teaspoon 1 and teaspoon 1 like that, 2 milliliters. And it will also work for tablespoons. All like that, nice and neat. And you can see there was the conversion. So, right way of using these types, and maybe I would say the natural way of using these types. Okay? So pretty cool, interesting stuff. And now what I'd like to do is talk about protecting data and interfaces. Now, by protecting our data, what I mean is we want to go and hide it, basically. And what we're going to do is we're going to use the mypackage.go, that separate directory that we were using previously. And what we're going to do is we're going to create setter functions and getter functions that are going to basically hide the data for anyone who tries to use our package. So I'm going to go into my package, and what I want to do is I want to, let's keep this function here because it's a useful function, and I want to create a type and a date, and this is going to be a struct, and this struct is going to have a day, it's going to have a month, and it is going to have a year associated with it. Alright, so we have all that. So what I want to do is, of course, I want them to be able to change the date, but I want to restrict how they can do it. And how I'm going to do that is with setter functions. And so let's create some. So I'm going to say function, and I have to tie this to our date that we have here. And I'm going to call this set day, and day int, so it's going to receive an integer, and it's going to return an error. And I'm going to say if the day that they try to set is less than 1, or that the day is greater than 31. Now there's situations where I could check the month and all that stuff and verify the date. I'm not going to do that. Okay, you can do that as practice. I'm just trying to keep this very simple. Well, then I want to create a new error, another thing we've never seen before, and this has to be lowercase. Incorrect day value is what's going to be passed back from that. And we'll need to go up inside of here and type errors. So errors, there we are. Okay, so we got that inside of there. Now, if we didn't have any problem with that, then we can say, all right, they gave us a proper day, and we are going to allow them to save it. And then afterwards, we are going to return nil. Okay? Now, we need to create one of these for day, month, and year. So I'm going to copy this, paste that down inside of here. And then this is going to be specific to month. So this is going to be month, like that. And what else do we need to change? Well, if the month, let's change this to just simply M. So we'll say M, it's still going to return an error value. If the month is less than 1, or if the month is greater than 12, well, then we know we have a problem because there's no such month. All right, so we will then come down here and say incorrect month value. And otherwise, we will allow them to assign a month like this. And we will just give it whatever they passed in and return nil. Have to do the same for year, of course. So again, set year. And we're doing this in mypackage.go, remember. All right, so just wanted to make sure I said that. All right, so in year, what do I put? Well, I'm going to say year. If it is less than 1875, I checked. The oldest person on Earth was born in 1875, so it's not possible. And then if the year, let's change this to Y. Y. All right, and if the year is greater than, well, what do we put inside of here? Well, I don't know if you remember, but in the past I showed you how to get the current year. So it's impossible to be born in a year that is greater than the current year. And if you want to get the current year, that's how you do it. except you're going to have to come up here and type in time. And there that is. All right, good stuff. And that is then going to change the year for our date to that, and this is the Y part. All right, anything else? Well, yeah, well, if they're doing the set, oh, also notice these are capitalized. They have to be, otherwise they are inaccessible outside of our package. And these are lowercase. They are inaccessible also. So if you want it to be accessible, uppercase. If you don't, then make it lowercase, like I did right there. All right. Well, so if we want to be able to get those values, we need to create what are called getter functions. So let's create them. We'll go function and d, and because this is part of the date that we are working with here, and then day, like that. And what is it going to return? It's going to return an integer. And we can just simply come in and say return d.day, like that. And then we need one of these for all of our other different date information pieces. So like that and like that. Up next, we are going to get our month. So just type in month like that. And then this is going to be D for the date. And this is going to be month for the month. And then this is going to be year like that. And then we are going to have year down here. So this is how we're able to access these. Also notice uppercase letters. All right, so we have all of those set up. And now let's go and use our main function that we had before. If you don't remember, all of this is in the app. So here's my package, and here is the main function. All right, so what are we going to do inside of here? Well, let's just demonstrate what encapsulation is. Okay, so I'm going to create a new date equal to, and it's going to be stuff dot date, and like that. And there's where stuff comes from. This is how we're able to reference it, and this is a module, and my package is in the module, and that is where we have all of our code hidden. So let's go and get a potential error here by saying date dot set month, see, uppercase letters, and we're going to say that it is 12, and then we're going to say if the error is not equal to nil, well then we're going to trigger an error, log dot and fatal, like that. And then we're going to do this for setting the day and also the year. So we got that. And set, let's do the day next. This is the most important day in history, what we're working with here. And what else do I want to do? Let's go down here, paste that there. And this needs to be changed into an equal sign, and this needs to be changed into an equal sign because we're not declaring it, we're just changing the value. And this is going to be set year, like that. And this is going to be 1974. Like I said, most important day in the history of man. And then what we can do is come down here and say format dot printf, like that. And this is actually the year that the people believe that we live in a simulated reality. This is the year that the specific date that they say is when the simulated reality began, if you're wondering. Okay, and like that, and like that. And then we're going to go call our getters to get all this information. So let's go like this and tab this over, and we'll say date dot and month is what we want, and then date dot, and we will get our day like that, and then we will go date dot, and we want our year like that. And there we go. And if we run it, boom, and it's printing out the string information, but you can see down here 12/21/1974. All right. So that is how we can use encapsulation in packages and modules to be able to properly encapsulate our data. All right, so now let's talk about interfaces. Interfaces are basically going to allow you to create contracts that say if anything inherits it, that they must implement some defined methods. So for example, if we had animals and wanted to define that they all perform certain actions, but they're in their own specific way, we could use an interface to do that. And let's just come up here and just create a interface. So I'm going to say type and animal, like that, interface. There we are, we created an interface. Then we're going to say anyone who inherits from this interface, well, you have to make an angry sound. Your animal must make an angry sound, and also it has to make a happy sound to equal out the world. All right, good. And let's just move this up here. Then I'm going to define a type. So let's say cat, and it has a string associated with it. And it is then, I'm going to associate a function just to the cat. So I'm going to say func. How you do that is you just put ccat, or reference that inside of it. And let's say that this cat does something when it attacks. Just to keep it simple, I'm just going to say cat attacks its prey. All right, so there it is. So this is associated specifically with this cat type. Now what I want to do is I want to return the cat's name, and let's just do something like, see, this has nothing to do with that interface. I'm just trying to explain how to separate things from the interface so that the cat has its own things it does and then things that it must do if it works with our interface. So we'll have that like this, and this is going to just return the cat's name. So there's that. And you can see the cat has a string associated with it. But it also wants to work with our interface. And what's interesting is that you don't have to actually define the interface that the cat is going to use the interface. All you need to do is create the functions, and everything is automatic. It just knows, hey, this cat wants to be part of this interface. Just simply by the fact that you went and created the needed methods. And maybe the cat, for its angry sound, says cat says hiss. And then for its happy sound, copy and paste, you could say the happy sound is going to say, and you can see that error went away because you implemented one of the functions but you didn't implement the other ones. That's not allowed. That's the reason why that error was on the screen there for a second. So maybe the cat says purr whenever it's happy. Okay, so we got all of those things set up now. What we can do is come down inside of main, and let's create a cat, and let's call this kitty2 cat, and equal to kitty dot and cat. And now down inside of main, we can say var kitty and say it's an animal, and kitty is equal to cat, and the kitty's name is kitty. And then we can come in and say kitty dot angry sound, like that. And we can also call methods defined in the interface for cats because of the contract. And another thing that's interesting is we're also going to be able to call methods defined in the interface for cats because of the contract. So we could say var kitty2 cat is equal to kitty cat. Whoops, it's a cat type, like that. And kitty2 dot attack. And execute that. And then you can also get the cat's name by saying, whoops, cat's name, like this. And kitty2 dot name. And run that. And you're going to see that it basically does what you would expect it to do. It just executes those different functions. All right. So there is a demonstration of how we can use interfaces. I have used them a little bit previously, and we will use them later on in the video also. But now I'd like to talk about concurrency. Now, concurrency is going to allow us to have multiple blocks of code share the execution time by pausing their execution normally. We can also run blocks of code in parallel at the same time. And concurrent tasks in Go are called Go routines and not threads, if that is at all confusing. And basically, to execute multiple functions in new Go routines, all we need to do is add the word Go in front of the function, and it is going to work. So let's create a couple different functions here. What's this from? I think this is just hanging out there. All right, so let's get rid of that. So let's create some functions, and I'm going to give you 3 examples using concurrency because it is important. I'm just going to do sort of just run these so you can see what these different Go routines do. I have to keep myself from saying threads. I less than equal to 15, so it's just going to run this code. Is all a Go routine is just a block of code, and we're going to, it's function 1 like this, and then we will print this out. All right, so that's the first one, and then we're going to create another function. It's going to count to 15 or something, or 10. Let's have it count to 10. So function print 2, and we'll change this to 10, change this to 10, and just change this to function 2 so that we can tell the difference between these different functions. All right, so then what we can do is just come down inside of main and go and print. Let's do the 15 one, and then we'll go. See, now it's a Go routine. That's it. Just put Go in front of it, and all of a sudden, Go routine, just like that. Just that simple. And if we run it, you're going to see that they are going to share time printing out all of this information. But they didn't. Why didn't they? Well, actually what happens is when the main function ends, then it just doesn't even call these functions. It just says, hey, I'm done, and that's it, and it doesn't do it. So if you want to pause the main function to allow for the other functions to execute, what we can do is we can use time to do this. So we can go sleep like that, and let's say we want to pause for 2 seconds. Say times and time dot second like that, and that's going to pause for 2 seconds. Of course, we have to come up here and throw time inside of there, save it, and run it, and now it will work. And there you can see that it prints out. So function 2 goes first. Well, how do we have this set up? We have function 2 is right here, print to 10. Print to 10 comes after print to 15, so what's going on with that? And it goes and it prints the 10, and then it goes and prints these guys like that. And we can go and copy this and throw this over here and see if that changes anything. Basically, what is going on here, now you can see things are even crazier. So it's printing out, function 2 is going 1, 2, and then function 1 gets an opportunity to print out 15 values, and then it goes back to function 2 and prints. The point here is whenever you are using these Go routines, you cannot trust in what order they are going to execute. So what we want to do is we want to work with something that are called channels. What channels allow them to do, and we're also going to use locks in an example that is going to kind of define what's going on. But basically with Go routines, you can have them communicate with each other with channels. And the sending Go routine is going to make sure the receiving Go routine is going to receive values before it also attempts to use them, which is very important. So let's come in and let's go and get rid of this. So let's get rid of these functions. Don't need them anymore. And inside of here, these functions are going to print in order using their channels. So I'm going to say function and nums1 channel chan int, and then we define channel like this, and it's going to print these one by one. So I'm going to say channel 1 is what's going to print, and channel and like this, and 2, and channel like this, and we'll put 3 inside of there, and then we'll create another function that is going to just print the rest of the numbers. So I'll do like this, and change this to nums2, and then change this to 4, 5, 6. So basically, whenever these functions are called, then they're going to execute each time. It's almost like next, which is also used sometimes whenever we're working with iterators. Okay, so down inside of main, what we're going to do is we need to create a channel. So we'll say channel 1 like this equal to, and make chan int, and it is only going to carry values of one type. That's important to remember. So let's copy this, paste this inside of here, and create channel 2, and everything else there is the same. And then we go and call these to execute. So we say go and nums1 and assign it to channel 1, and we're going to do basically the same thing with our other go routine. So we'll change this to 2, and this becomes channel 2. And then what we can do is we can go and call them with print one by one, and they will output the information one by one. So there that is, and everything will be in order. And copy, and let's just go paste and paste and paste. There's 6 values we want to get. And we can get channel 1, channel 2, and change this to 2, and change this to 2. And now we will call them in order, and we will know we are going to get them in order. Of course, you could use a for loop here, but I'm just trying to keep it simple. And you can see now we get them in a defined order, and we could run this 500 times, and we would always get them in a very, very specific order. All right, a little bit on channels. Let's get rid of that. And another thing I want to talk about, let's actually go and create like a real project this time. What I want to do is I want to try to simulate customers accessing a bank account, and I'm going to lock out customers so that we can't overdraw the account. And let's go and actually, make this somewhat real. So I'm going to go type and account, and this is going to be a struct, and the struct is going to have a balance. I'm just going to make it an integer instead of a float. And then we say lock sync dot mutex, and this stands for mutual exclusion, and it just means that we are going to be able to only allow one customer to access this account at one time. So now we need to go and create some functions that can be used to work with our account. So account like that, and let's say we want to be able, I'm going to use uppercase letters, maybe we want to export this. So I'm going to say get balance like that, and int like that, and we're going to go and get our lock and all that, and that's going to lock the account down, and then we are then going to unlock the account. So we're going to get the balance, and as soon as we're done, we're going to unlock the account. So we'll say defer a dot lock dot unlock like that, and that just means whenever we get to this curly bracket and we're done outputting that, it is going to unlock the account so that something else can go in and access it. But what this is going to do is just simply return a balance. Now, another thing we'd like to do with our bank account is withdraw money. It's a real purpose, and I'm not going to do deposit. That doesn't need to be done. You can do that for homework. All right, so I'm going to go reference our account again, and I'm going to say that I want to withdraw money. So let's just call this withdraw, and there's going to be a value, which is going to be an integer. And I'm accessing the account, so I want to lock it down so that nobody else can access my account while I'm withdrawing information. Don't forget to do defer to unlock the account after our function is done. So we'll say unlock like that. And then I'm going to say if the value is greater than the balance. Well, that's a problem. So they're trying to withdraw more money than they actually have in the account. Well, I could do an error here, but I'm just not going to. I'm going to just keep it simple. Okay, so not enough money in account. So that's going to print out on the screen if they try to take more money than they actually have. And otherwise, if not, if they have the money, well, we're then going to come in and say printf like this, and we're going to say how much money we want to withdraw. So d withdrawn and balance, and there it is, and new line. Okay, and then I need to go and get said values out of here. Oops, I lost my parentheses. All right, there it is, and I'm going to just say the value they went and tried to take out, or the value they did take out, and then I'm also going to put the new balance inside of here, and also I'm going to say a dot balance and subtract that from that. Okay, so that is how we withdraw value or withdraw money out of there, and also access the balance. So down inside of main now, let's go and simulate having multiple different Go routines come in here and access that information. All right, so let's create an account. Let's call it ACCT account like that, and we'll come in and give a balance. It's lowercase, I believe. Balance is equal to 100. And then we can go and access our balance just to see what it is. So balance like this, and comma ACCT dot and get balance. And then what I want to do is create a for loop that's going to create a whole bunch of Go routines that are going to go in there and try to take out money as quickly as humanly possible. So let's say I have 12 customers all trying to access the account all at one time. Go routine becomes a Go routine just by putting Go in front of it. Account like that, and withdraw, and I want to withdraw $10 every single time. And then I am going to call sleep on this also. So let's say sleep, because remember we don't want the main function to end, and we'll just time this for a brief period of time. We'll go time, and I need to come up here and put time inside of here. So there's time. And there's time, and I think that's all we need to do, and we can run it, and you're going to see it goes really, really fast. But basically what happens is we go and we ask how much money we have, $100, and then they try to withdraw $10, and you will see the balance goes down 90, 80, 70, 60, 50, da-da-da-da-da. And then we get to the point where we don't have enough money and no more access. All right? So cool stuff, and that is a little bit on concurrency. Maybe touch on it a little bit later on, but now I'd like to talk about closures. All right, now we're going to talk about closures. Now basically closures are functions that don't have to be associated with an identifier, but very often they are associated with a variable. So let's just go and create a closure that sums values. So I'm going to go int sum, that is my variable that I'm going to associate, and here is the closure. It's just func like that, and I'm going to say x, y, and both of those are int, whoops, int like that, and it's going to return an integer, and we'll say return x plus y like that. Now what we can simply do is go 5 plus 4 is equal to, and int sum 5 and 4. And got that all set up. Whoops, I accidentally put a period there instead of a comma. Now it's fixed, and we can run it, and you're going to see that it works. Now what's really great about, well, I'm going to cover something else. Something that's important to know is that closures can change values outside of the function. So for example, if you have sample 1, something like this, and then we go change var equal to and func, and then after that sample 1 plus or equal to 1. Whoops, what did I do here? Oh, that works. That works. Okay, so we have that, and then I call change var, and then outside of the function I say something like sample 1 is equal to sample 1. Now you can see sample 1 is 1 here. Inside the function we changed it, but we are outside of the function right now. So previously with functions that would have no effect, but with closures you can see that yes indeed you can change those values. Another thing that's interesting is you can actually pass a function to a function. So let's come up here before main and let's create some functions. So I'm going to create a function here, and I'm going to call it use function, and f and func, and it is going to, this is a function being passed inside of here that's going to receive an integer, and then it's going to return an integer, right, like that. And then we are going, whoops, let's go like this, x and y and integer. So it is going to get those values. Basically, what it's going to do is it's going to receive a function. It's going to this function is going to return an integer, two parameters inside that are going to be integers, and then it's going to also receive a value x and y. Also, both of those are integers. Oh, by the way, I just showed you here. You can name both of those at the same time. Something different. Okay. Constantly trying to fit new things in. So what this guy's going to do is then go answer like this, and it's going to go and output what the function that was passed inside of it is calling, saying we're going to pass x and y to that function. Now, you can come down here, go function sum values like this, and it's going to receive an x and it's going to receive a y, both integers. It's going to return an integer. What does this look like right here? Okay, it's the same as this right here. Okay, that's the difference, or they're the same thing. All right, and then it's going to go return x plus y, and if we save that, and then we come down inside of our main function and call use function, and we go something like sum values like this, pass 5 and pass 8 inside of it like that. We're then going to be able to run these guys. And we can run it, and mix name and unnamed parameters. Oh, what's that guy going to do? Missed an error here. Not sure why it didn't work. I just saved and then it did work. So sometimes just if Visual Studio gives you a weird error, just go and resave it. Sometimes you have to turn Visual Studio off, turn it back on. Oh, Visual Studio Code anyway, and then it will work. And you can see here that the answer came back as 13. So we passed the function inside of there, then had that function call this function, passed x and y that was in here, and then it returned back here, and then you get 13. All right? So a couple examples using closures, and now I'd like to talk about recursion. All right, so with recursion, it's going to occur anytime when a function is going to call itself. And one thing to be aware of is there must be a condition in that function that ends this calling repetitively of a function. Now, just the easiest way to understand recursion is just to see it. And one of the most common things to do is to go and calculate a factorial. So I'm going to say factorial and num and integer, and it's going to return an integer. And then we're going to have our condition right here that's going to end the calling of functions. So if this number ever is equal to 0, it is not going to call the function again. Instead, it's going to return the value of 1. Then we're going to say return number times, and here is where we call our factorial function again, and we're going to decrement the value of 1. Or we're going to decrement the num variable by 1. As you can see, eventually it will get to the point where this is equal to 0. And that's it. That is how you calculate a factorial. You just go into main and just go PL like this, and factorial. And let's get the factorial of 4, and I'll explain exactly what's going on with the factorial. If this is at all confusing, don't worry about it. Normally an example will help out a lot. And if we run this, you will see that the factorial comes back as 24. Well, how exactly does that work? Well, let me just show you. So, factorials, basically, this is the whole thing. We pass in a 4 value. That is what's going on here. We then go into the factorial function. And the factorial function, here is the 4 that was passed inside of it. And the factorial function is then going to decrement. So it's going to have 4, the original value passed in, right here and right here. And it's going to multiply that 4 times factorial minus 1. So then you get this guy, factorial 3. Well, guess what? That is factorial 3 here. This is the 3 being passed in. It gets decremented to 2. And then we have the 3 here. We don't have the 6 and the 2 yet. We're waiting to generate those. So then we get 3. We pass the 3 into here. Or we pass the 2 in. That's this guy. There's the 2. We decrement this down to 1. Whenever we do that, we hit our condition here where this is going to give us a value of 0. This is going to become a 1, which ultimately makes this a 2. This 2 ultimately goes up here, which creates a 6. That 6 goes up here, and that's how we get our final value of 24. All right, so rough overview or example of recursion. You can think up some other things, maybe go into Google and say something like uses for recursion and find some examples and try to code that on yourself or with yourself. And what I'm going to do now is talk about regular expressions. I'm just going to give you a couple examples here. But basically, I could do a whole entire tutorial, and I've done entire tutorials on recursion. You can just type in regular expressions, Derek Banas in Google, and you're going to see a whole bunch of them because I've done them. I'm not going to get into that, but I'll give you a couple examples, and I'll cover all the specific changes that you will get with Go. So we're going to go inside of main here, and I am not going to do any functions or anything like that, so we can just come up here. All right, so let's create a string like this. And what I want to do is this string is going to have the ape was at the apex, like that. All right, so what we're going to do now is I'm going to create a regular expression, and it is called a match. And I'm going to show you a couple different ways of using regular expressions. One's going to be compiled, and the other one's not going to be compiled. So we'll say match like this. And I'm going to create a regular expression. So I'll go regular expression dot match string. And then I'll put the regular expression inside of it. And a regular expression is just a series of codes that help you identify what you are searching for. Now, what I'm specifically searching for are the letters APE. APE. So I'm going to put APE in like that. Now, what I'm also looking for is the letters APE, and I do not want, that's what this caret is, it's a not. I do not want that to be followed with a space. So I'm specifically looking for apex in this situation. That's what I'm trying to match. I'm trying to not match this because there's a space there. I'm trying to match apex. So anything that is not followed by a space is going to work. And I am going to come in here like this and then go RESTR like that. And this is just going to tell me if I have it or not, if I have a match or not. Just come up here, regular expression like that, and then come down here and go PL and match like this. Save it, run it, and it's going to say false. Okay, so it could not find that. Why could it not find that? Well, in this circumstance, this comes to an end. There's nothing there. All right, so that is the reason why we were unable to match that. Another thing, let's go and actually do a compiled regular expression. So I'm going to go RE and STR2 and equal to, and I'm going to go cat, whoops, put this in parentheses. I'm going to search for cat, rat, mat, whoops, mat, fat, and pat. Okay, so we got all those things in there. I'm going to do a compiled regular expression like this, underscore, equal to, and I'll go regular expression and compile, and then we'll be able to use this in a lot easier ways. And compile, I would think I know how to spell that, right? Compile is just C-O-M-P-L-A-E. Okay, so compile. And inside of here, the regular expression is I want to match these letters, C, R, M, F, and P. And then I'm looking for the letters at to follow after that. So those are the specific things that I am looking to search for. Now, what I can do here is I can say, let's say I want to find out, did you find any matches? And I'll go PL like this. Did we find a matching string or not? And let's go like that. And we can just go R like that, our reference to our regular expression, and match string like that. And then inside of there, we're going to put our string. So we'll go RESTR2. And there that is. And I'm going to copy this, and I'm going to do similar things for finding other different things. Let's say that I want to return the first match. I can say, let's just call this find string, and we will go and just go R, and we're going to change this to find string. So we'll do find string like that, and that stays the same. Up next, let's say that I want to return the starting and the ending index for the first match. Let's change this to index like that. Find string, or this is going to be find string like that, and index like that. So let's get that. Whoops, string index like this. And also, that's it. That's all I need to do. So another one. Let's say I want to return every single match I have. So what did I do here? I typed in index G. I don't want that. Get rid of that G. Okay. So I'm going to return every single match. And this actually comes back as a array. So you could cycle through it or whatever you'd like. And let's come get rid of this. And I'm going to change this to find all string like that. And what you need to do here is change this to -1 if you want to find every single string. I'm going to do something kind of similar. Let's go copy like this and paste this inside of here. And in this situation, I want to find the first 2 matches. So I'll just say first, oops, let's just go first 2 strings, whatever. There's that, and find all string, and I'll just change this to 2. That's what I'm looking for. And then what I can do is I can go and get indexes for every single match. And this one is a wordy one. So we're going to say something like all, let's get rid of this. I'll change this to all submatch index. Whoops, submatch index. There we go. And then we will go and cycle through all these. And this is actually find all string. And then it's going to be submatch index like that. And then we'll pass in our, oh, there is our string right there. And I'll leave this as -1 as well. And let's say I want to replace all matches with the word dog for our final example. So throw that there. And I'm going to get rid of this altogether. And like that. And then I'm going to say replace, whoops, and it's going to output this. I'm going to say replace all string and inside of here. And what I want to do is put the word dog everywhere we have a matching string. And I think that is just about every single thing. Oh, we got an error. Let's figure out what that is. And again, it was a weird error that was brought about because I had to save it. I don't know. Visual Studio Code's messing up a little bit. All right, did we find a match? Yes. Find string, and the find string in this situation is going to return the first match, which is rat. You might say, why is it not matching cat? This is lowercase, that's uppercase. Index, it's going to find the beginning and the ending of that match. There it is. We're going to get all the matches right there as an array. First 2 strings, and then all sub match indexes. Again, it's going to give you the beginning and the ending for all of the matches index-wise. And here you can see we replaced every single match with the word dog. Okay, so there's a rundown of a whole bunch of different things you can do with regular expressions. Again, if you want to learn more about the really awesome thing about regular expressions is they almost always work exactly the same in every single programming language. So if you learn how to use them, just type Derek Banas, regular expressions in YouTube, boom, you'll find a whole bunch of things. But now I want to talk about automated testing. Now with automated testing, automated tests are going to make sure your program still works while you change your code. And because a common error is, as we're coding, we will go to try to have our code do something very specific, and it will do it the right way, and we'll say, great, it works. And then we'll move on and we'll do something else. And whenever we do that, sometimes we break the code that used to work. So automated testing allows us to go and verify that even though we made a change, that we didn't break anything that we created in the past. So what I'm going to do, I'm going to come into my GoTut here, and I'm going to create a new directory. So bounce inside of there, and I'm going to call this app2 for simplicity reasons. And then I am going to, over here, going to change directory to, let's go back, and then we'll just say change directory to app2, like that. All right, so we're in app2. What I want to do now is inside of app2, I'm going to go and create a file. And I'm going to call this test email, like this, and test.go. All right, so here is a brand new test email, test.go thing. And then over inside of here, I'm going to go mod init app2 module. We've already talked about modules. If you skipped that part, well, then go back and look in the table of contents. All right, so there we went, and we created that module. Now I have to go into these guys and actually create both of them. So I have test email test, and I need another one, and it's just going to be called test email. For some reason in my wild brain I thought I already did that. So I'm going to call this test email.go. These have to have the same name. So I have test email go and test mail underscore test. Okay, so it's test email dot go. I need that file right there created. That's what I'm currently in. Let's go like this and like that, and then I'm going to have another one, and let's go copy. I'm just doing this in case you can't see. Underscore test go. All right, so those are the two files that I'm going to create, and I'm currently in test email right now. So I'll go in here and test email go, and I have to create a new package. So I'll go package, and I'm going to call this app2, and I need my imports again, and I'm going to need format. And what this is going to do is it is going to verify that I have an email that works. So I'm going to pass a function. I'm going to have a function. I'm going to pass it an email, and it's going to say, hey, that's a valid email. Hey, that isn't a valid email. So I'm just going to call this is email. Again, I want it to be uppercase so that I can go and get this from outside the package, uppercase. And I mean the is email part is uppercase. This part right here has to be uppercase. Okay, so, and then what you need to do is go string and error like that. On that. And here what I'm going to do is I'm going to use a raw string here so that I don't need to double my backslashes. This is a regular expression. So here's another example of how to do a regular expression. And I'll sort of step you through exactly what's going on with this regular expression. So regular expression dot compile, and then I'm going to put inside here, whoops, I want this to be a raw string. So for raw strings in Go, you do a back tick. And here's the regular expression. So basically, what I'm saying here is the beginning of the email is going to have letters or numbers, dots, underscores, percent signs, plus signs, negative signs, and it's going to have 1 to 20 of those, and then it is going to have an @ symbol, and then it is going to, again, in what follows the @ symbol is going to be letters or numbers or what have you, dots and dashes, and there's going to be between 2 to 20 of those, and then there's going to be a dot, and then I'm going to have any type of letter, uppercase or lowercase, and I'm going to have 2 to 3 of those. Okay, so it's a generic email. It might not work in all circumstances, but in many situations it will work. And like I said, this is a tutorial. This isn't meant to be the world's greatest email catcher. All right, so what I'm going to do is I'm going to say if r, and I'm going to call match string. If you remember what match string does. If you don't, go back a couple minutes and learn about regular expressions. So I'm going to say match string. Well, this is going to be S in this situation because the string was passed inside of here. All right. And if I get this, if this gives me a positive, I'm going to say return. And I'm going to say something like valid email, like that. And then I'm going to also put nil inside of there. What's that mean? That means that this was a valid email and we didn't get an error. Otherwise, I'm going to say return, and I'm going to return nothing. And then I'm going to return that I want an error, that an error occurred with this. And I will say not a valid email, like that. Okay, so that is what this guy is going to do. Now over in the test part of this guy, again, I'm going to use the same package. So I'm going to say package app2, and I'm going to say import, and this is where we're going to be testing everything. Call this testing like that, and let's go to the next line. And in here, I'm going to have a function, and it's going to be called test. Capitalize this, test is email. Same exact name, except there's a test in front of it as this. This is called is email. This is called test is email. And we'll put a T inside of here. And this is what we need settings-wise to be able to verify this, whether the function is operating properly. So I can do an underscore like this, and error, colon, equal to, call is email like that, and pass in hello. All right, clearly not an email. Jump down here, and I'm going to say if error equal to nil. Well, in that situation, I'm going to go T dot error, and I'm going to say hello is not an email, like this. So we can go and do that testing. And then what we do is we bounce over here to run our tests. Make sure you're in the right directory. I'm in the app2 directory. So bounce over here. And to do your test, you just say go test -v, like that, and run it. And it's going to come back, and it's going to say, hey, it passed. That means that your function is operating the way that it should work. All right, so that is a positive thing. Now we're going to do something similar here. We'll do like this. And what would happen is you're going to run this every single time, and then you're just going to automate it. And it's just going to do it for you. You're going to, hey, by the way, I'd like to check to make sure I didn't break is email somehow. And you just keep running it. Remember, if the first time you declare a variable, you're going to put the colon equals, and afterwards you're not. Okay, so I'm going to say is email, and then this situation, I'm going to say Derek at, where's my at symbol? at AOL.com. So there you go. That is a valid email. And in this situation, I'm going to say is an email. So I'll say Derek at AOL.com is an email. And let's do another check inside of here also. And we'll bounce down here. And we'll say da-da-da-da-da. And what we're going to pass in this time is Derek at AOL. Knock the .com off of there. And in this circumstance, we would say not equal to, because we're on purpose going to do like the reverse for this, just so we can see that the test worked and there was an error. We're sort of artificially creating that error. And we'll go in here and create this like that. Jump over here and run our test. And you're going to see it's going to fail. See, it failed? And that's what it did. I mean, I on purpose made it fail by changing that equal to and a not equal, but whatever. So I think you get the idea of automated testing. And it normally wouldn't work like this. You're mainly going to use it in circumstances in which you just want to verify and you want to write additional code that isn't based off of his email, but that's what you get. All right. Okay, so there you go, a whole bunch of other things. And for my last example, it's going to be a little bit more complicated. I'm going to develop a web application. Now, our Go apps are going to be able to be run directly inside of our browser on the back end. And so to create one, what we're going to do is we're just going to go to GoTut again, and we're going to create a new folder. And I am going to call this just Web App. And then inside of it, we're going to create a couple different files. So first off, I'm going to create a new file, and I'm going to call it webapp.go. And I'm also going to create another file, and it is going to be called new.html. And we'll create another file, and it's going to be called to-dos. And we're just going to store everything on the file system rather than getting involved with databases. And then on the final one, what else do we want? Well, we want our main view.html file. So there we go. We have 4 files. And we're going to start off in the web app part of this little application. And we're basically just going to start off everything. It's just the same sort of stuff we've already covered. And really the only difference is we are going to be using a couple new libraries, but also we are going to be using some notation inside of the HTML to get from our Go application to the browser. So what are we going to import? A good bit of stuff. So let's go import. And we're going to be reading and writing from the file system. So we're going to have our buffered IO like we've used before. We're going to use format again. Then to work with the HTML, we're going to go HTML template. And we are going to be logging errors, and net HTTP is going to allow us to respond and make server requests. And also we're going to need OS because we're working with the file system like I said before. And this is just going to be an extremely simple to do application. It's very, very simple. I want to keep it simple so that it's understandable. So we're going to create a struct, and it's going to be called to-do list. And we're going to keep count of how many things we have to do. And we are going to have a array inside of this, which is going to be our list of to-do items. And let's get our error checking, and let's throw it into a function. And let's just call it error check, receives errors. And then we're just going to say the same thing we've done countless times. At this point, you should really remember a lot of this stuff. And nil, and we'll go and log any type of error we may have received. So there's that. What else are we going to do? Well, basically, we're going to have to create a writer, and it's going to allow us to write to the browser. So to do that, we say function and write and writer HTTP dot response writer. And let's move this out of the way here so we have a little bit more room. This is actually not going to matter much this time. And basically, with it, we're going to create a message and add it to the response that is then going to be displayed inside of our writer. So here is our message, and we're going to pass the messages to this function. It's going to put it in the browser. Then let's go, and we're going to need to perform some type conversion to bytes to be able to use this string message that is passed inside of here. So we'll say writer dot write, and this is going to be a byte array. That's what we want to convert to. So this is just casting like we've done. And we can just go and call our error check and pass our errors inside of here to handle that. All right. So after we have the writer all set up, well, now what we need to do is create individual messages that we are going to write to the screen based off of the directory they go to on our website. So let's say that we just want to do something really simple. We're going to say hello in English and in a couple other different languages. So say English handler, and we're going to have our writer passed inside of here, HTTP, and this is going to be a response writer. So response writer, and also we will have our request that's going to be sent inside here. I'm not going to go over how the internet works in this video. There's plenty of other things I've covered here, and I don't need to do that also. And then what this is going to do, if you want to write to the browser, you just call your write function we created and pass our writer inside of that, and then whatever message we want to display. Now, like I said, very, very simple. So this is just going to say hello internet like that. And let's say that we would like to also be able to, and that's it. That's literally it. So whenever they go to a specific part of our website, a directory, we are going to automatically call this and output this to the screen. Now we could also output HTML, which I will show you how to do. And we could do this for a couple different languages. Why don't we just have it be really simple and just do two. So we'll have a Spanish handler, and then this is just going to be hola. So there you are, and you could do some more if you'd like. All right, so that is how we're going to be able to very quickly just output a simple line of text whenever they go there. Another thing I'd like to do is to interact with them, and what this is going to do is actually put a view on the screen, and then it's going to use some different templates to be able to output a slightly more complex web page. So let's just call this interact, and this is going to display a list of to-dos and things like that. So I'll call this interact handler. Again, it is going to receive both of these. So let's get this, and there we are. So we got that set up. And then what this is going to do, a little bit more complicated, I want to get I'm going to have like a text file to do. So let's come in here and say something like buy dinner and wash clothes. Okay, there we are. So we have this list. So what I want to do is I want to be able to get that text information. So to do so, we're going to say, I'm going to call this to-do vowels. Oops, vowels like that is equal to, and get strings, and this is going to be to-dos dot text. And I'm going to create a function that is going to get those strings. So let's just create that first. Where do I want to put it? Let's put it up. Let's put it right here. So I'm going to come in here. I'm going to go function and get strings. And we're going to be passed a file name, and which of course is a string. And it is going to return an array of strings. And so let's go up here. I'm going to go var lines. We're going to cycle through and grab the lines of text one by one. So that's going to be called lines. And I'm going to try to open the file. Maybe it doesn't exist. Equal to, and we'll use os.open. So we're just using the same stuff again. We're just adding incrementally more information. So we'll say file name. And of course, if we do this, we have to go and check that the file actually exists or not. So is not exist, and then error, throw this here, and return nil. And then let's call our error checker to handle that for us. So error check, error, and of course we're going to want to close our file. So we'll defer to the function closing, and that's when our file will close. So there that goes. And then we also want to go in here and read lines of text from that to-dos.text line that we have right there. So to do that, we are going to get a buffered scanner. So there that is. And buffered io.new scanner, and pass in our file to handle that. And then we're just going to cycle through all of the individual lines and scan those in, and then we'll be able to display them in our browser. So like this, and lines is going to be equal to append lines and scanner text, and boom. And again, after we do all of that, we can do another error check if we would like. Pass in, well, this is going to be scanner error in this situation, so we'll say scanner dot error. There we are. And then after we do all of that, we want to return our lines of text, which we will then use and display in our browser. Okay, so we got all of that set up, and I'm getting an error here for file name. That's because that's not capitalized. Anything else? No. Okay, so now we come back down to our interactive handler that's going to, do, it's display to-do list information and maybe add options for them to add additional to-dos and things like that. So another thing you might want to do is if you would like to print to your terminal as your program runs, this is how you do it. You could do something like just print F like that, and maybe we want to print out our list of to-dos or something like that. So we could do this, number V, and there, throw a new line inside of there, and this will be to-do values. So that's going to get that. And did it get rid of my format? Yes, it did. So let's throw format back inside of there. Come back down inside of here. So that's the way you can print to your terminal to see what's going on with the website. You could print out errors or whatever you would like to print out, I guess. Now what I'm going to need to do is I'm going to create a template that is going to use an HTML file to display this information on the screen. So I'll go template, error, like that, template, and we call parse files, and we're going to be mixing together our template, our HTML, and plug in all of the information we want. Let's call our error checker again. And then, after we do that, I want to create a to-do list with the number of to-dos as well as the to-dos that we have inside of here. So I'm going to go to-dos like this and to-do list, and we will have our to-do count, and that is going to be equal to the length of our array called to-do vals. Oh, that's to-do vals, like that. And also, we're going to have our list of to-dos, which are going to be in that array. So to-do vals, and then we'll cycle through all of those to-dos and display them on the screen. Also, I want to write the template to the response writer. So let's go like this, equal to template, like that, execute, and pass writer, and to-dos, and I'm getting an error on template up here because it was deleted. So let's just come up here like this, HTML and template. And it's really neat whenever it all comes together here, so just bear with me. Just have to do a couple little changes here and there. What else would I like to do inside of this? Well, I'm going to have to go and connect the different directories to the different function executions. And I'm just thinking, do I need to do anything else with that? Well, one other thing I'd like to do is allow them to add new to-dos. So let's go function, new handler, and writer. Let's just grab this. So writer, always using the response writer and the request itself. So copy and paste this inside of here like that. And let's get this. Now create again, you're going to do the same thing. You're going to create a template using the HTML. I'm going to write the HTML here in a minute. So I'm going to say template error equal to template. And again, you're going to do parse files. And the name of this HTML file is going to be new.html. And it's just going to allow them to put a new to-do into it. Call our error check again, save ourselves a little bit of time, and then error is equal to template.execute and writer and nil. All right, so we got that set up. And now what we're going to be doing is we will have the user go and enter a new to-do using our new HTML page. And then we're going to, whenever they do that, we're going to call another function, and it is going to store the new to-do. And then after it stores the new to-do, it's going to send them back to the indirect or interact page where they'll get a list of to-dos and then the option to add additional to-dos. So we'll say create handler, and again, gotta do our writer and response, all that, and we're going to go to-do equal to request, and this is going to be the new to-do that we are going to write to our text file. So to-do, and this needs to be inside of quotes, and this is the value that's going to be passed from the form to the create handler. I'll create all the HTML in a minute. Now what I need to do is I need to define the options for working with our file. So I'm going to say options. We've covered this also, OS, and I'm going to say read and write is what I want the options to be. So underscore read, write only, and we'll stack these. and also have append like that. And we'll also have create. os.o_create. And then we will have, we'll actually open the file with those options. So we'll say file, error, potential, opening files. We'll say os.open file. And the name of the file is going to be todos.txt. And we have to list our options that we're going to use. And let's go down to the next line so we have a little bit more room. And then I'll also have the permissions for this. So I'll say file mode and 0600. All right. So we have that set up. And after we do this, let's do another error check like that. Let's go up here. And then I'm going to append new text to that file. So like this, and error is equal to, and call format dot f printf, or there, f print, and we'll do f print line, so everything's on a separate line. That makes sense. And to do, come down here, and again, we'll do another error check like that. Then I'm going to close our file. So I'll say file dot close. Could use defer if you wish. Do another error check just in case something went wrong. And then after we got that information from the form and we wrote it to the file and we closed the file, now what we want to do is a redirect to another part of our website. So to do that, and that's going to be back to the interact page, which is going to show all the to-dos and also the option to add additional to-dos. So we'll say redirect and pass the writer, pass the request, and then we're going to display where we want to send them. And this is going to be backed to interact. And then you also are going to have to put inside of here a status, and what we're going to use is status found, and that's okay. And there you go. That's all of the main functions that we're going to use except for the main function. So just verifying, yes, that looks good. Okay, so what we need to do now is go and create our main function, and all it is going to do really is it's going to tie different directories in our website to all these different functions that we have right here. So I'm going to say func and main like this, and http dot handle func, and then if they go to the directory called hello, it's going to do that English version of hello. So we'll just do English handler like that, and then we're going to make one of these for each of our different parts of our website. So let's do hola, so hola, and then this is going to be Spanish handler, so Spanish handler, and do another one, and this is going to be our interact page, which is going to be our main part where it's going to list the to-dos, and it's also going to give them the option to add additional to-dos. We're going to have our new page, which is where there's going to be a form that is going to allow them to add new to-dos. So we'll say new handler, and isn't that what I called it? New handler? Oh, new handler. I just have this lowercase, so let's make it like that. And come down here, and that's good now. And then the last one is going to be create, and it's a temporary stop-off point. We go from new to create writes to the file, and then create sends us back to interact, where we did our redirect here. So create, and then this is just called create handler. So create handler. And then all we need to do is add the ability to listen for browser requests and respond to them. And it actually is only ever going to receive a value if there is an error. So it's just going to sit there and do its job. So we'll say listen and serve, And we are going to define that we're doing this on a local host because that's easy. And that's going to be our 8080 port, and then pass in nil. And like I said, this only is ever going to get a value if there is an error. So we want to handle that potential error like this. And there we go, and there we go. All right, so that's all the code that we have. And now what we need to do is just go inside of here and write all of the HTML. So again, this is just regular HTML. So we're going to say HTML, and we're going to do something like to-do list, like that. And then we're just going to create a div. I'm keeping this extremely simplistic, so let's just go div. Now, what we want to do here is we want to display the number of to-dos that have come across. So we just use this template. So we'll go to do count. And that is, boom, to-dos. All right, so there you are. This is going to take this guy. Where is it? Over here. It's going to take what we have stored inside of this struct, to do count. And it's going to display it inside of our web page. One thing that's also kind of interesting or useful is maybe you want to put some comments in your code. This is how you do that. So we could say something like displays number of to-dos. All right, so that's how you do a comment inside of Go. All right, and that'll be inside the browser, and of course it won't show. Another option I'd like to do is, let's say that I want to give them the option to add a new to-do. You just go like this, and this is going to redirect them to the new directory. And there we go. And I can do something like add a to-do. And if they click on that, it'll go to the new directory. They can add a new to-do. It's pretty straightforward. And then what I want to do is under here, I want to cycle through and display all of the to-dos that we have stored in our file. So again, I don't need to do that. How you do this is you just say range, and then your to-dos, which are in this struct, say to-dos right here, we want to get all of those different arrays, and we want to cycle through and print each of them on the screen one by one. So we'll go to-dos like this, and then let's say we want them to be separated, so we'll put them inside of paragraph tags. And then to get the individual thing that comes out of our array, we just put in these curly brackets and a dot, and then closing curly brackets. And that is going to do that. And then after this, to end the ending for our looping structure that we have here, is just to type in end. Okay? I think I did all that right. The only other thing left is our new page, and we're going to have to come into it and go and provide a simplistic form. So I'm just going to say h1 like this, add a to-do, and then let's go and create our forms system here. So we'll just say form action, and where did we say that we were going to send these commands? Well, to the create directory, or this form information anyway, actually this form word. And then we're going to use post for this. And let's get this out of here. And there we are. Okay, so that's good. And then after we do this, let's throw this in a div. And we will get input from our user, which is going to be text. It's going to be whatever the to-do is that they want it to be. I keep doing that because the auto completion changes whenever you're doing this. Okay, so we'll say to-do. All right, and that's what we'll store its name as. Now, if we go back to this, you'll be able to see it. So where is create? Create is right here, and the form value is to-do right there. And that is how we are getting it from our browser. So there is our to-do. And then afterwards, let's do this inside of another div. We're going to just have a submit button. So we'll say input type is equal to submit. Okay, super, super, super simple. Nothing that complicated. All right, so do this and close that off and save that. Now, if we want to go in here and actually run this in our browser, as long as I have everything set up properly, well, first off, I'm going to have to go into the correct directory, which is web app. So change directory to web app. And if I go directory, you can see all the files there if they were there. Let's try directory again. There you go. You can sort of see them. Anyway, it doesn't really matter. We know they're in there. So what we're going to do now is run our web app. And to do that, you just go and run and web app dot go. And as long as I don't have any errors, it should work. Looks like it did. And if I go to localhost, it says hello internet, which you can see if I zoom in like that. And the other one was, I don't even remember, what did I call the Spanish one? Okay, so let's go back into our web app and let's open this up. Don't need this at all anymore. That's going to continue running until I shut it down with Control C. Hola, that's what it was. So let's go hola and like that. And it's going to go hola internet. And then interact was where we were going to have our to-do list. There it is. There are 2 to-dos. I should put a new line here because that looks bad. Anyway, you can see we were able to read from the file and display those. Of course, you could use databases and all that. Let's come in and add a new to-do. What are we going to have here? Run, or let's say clean freezer. Okay, so there that is, and clean freezer shows up. All right. So there you go, guys. There is a rundown of the Golang language. I did my best to create a full course on it that would cover just about anything you could ever imagine. Or at the very least, I think that you will have no problem learning more at this point, which I think if you work through and run all the code and experiment a little bit, you're really going to master this language. If you want to install Go, obviously you have to. You're just going to go to go.dev and download. And then you're going to find your chosen operating system, and you're going to click on one of those guys. It's going to open up a auto installer. Of course, you're just going to click next a whole bunch of times, except terms next. Again, you're going to, it's more than likely, just put it in the default directory. That's what you want to do. And then you want to click on install. And then after that, finish. And then if you want to go and verify that Go's been installed, you're going to go version in your terminal or in your command line. And you should see something along the lines of 1.18 or something like that. Then you're going to want to set up Visual Studio Code. So you're just going to want to go to your extensions. Looks like little Tetris pieces over here. And you're going to type in Go. And then you're going to want to download this guy or install this guy, the very first result that comes up. Then you're going to see a window that looks like this. And down here in the right-hand corner, you should see a installation. It's going to tell you to install some different requirements. So you're just going to click on Install. And all kinds of stuff is going to go on over here, and a whole bunch of things are going to install for you. At this point, it's probably a good idea to go and just do a basic hello world, which you should have no problem doing. Just copy this code right here. Then over in the terminal part, you're going to want to change your directory to whatever directory you want. You have your file stored inside of. And then to run your application, you're just going to type Go, run, and whatever the name of your Go file is. And you should see hello Go. Another thing you should do is update everything. So you're going to want to come up here. And this is going to be in your command palette. So you're going to go View and Command Palette like that. And type in Go and start typing in update. And this is going to pop up. And you want to click on this guy. And then you want to select every single one of the things that pop up down the side here. So you just put check marks in all of them. Click on OK. And then a whole bunch more stuff is going to install for you. And then on top of that, if you want to run everything in the terminal, you're just going to go to your extensions again, type in runner, and you're going to see Code Runner pop up inside of here. And you're going to click on install, of course. And Code Runner is going to install. Then you'll be able to run all of your code directly in the terminal on your screen. But to finally get that to work, you're going to want to go into your settings. It's under Preferences. And then you're going to type in at ext formula Hendry. Here, let me show you actually where it is. It's actually here. Let me show you where it is. So you're going to go to extensions, whoops, like that, and you're going to find your code runner. So just type in runner, whoop, run, open that up. You're going to go into settings inside of here, extension settings, and you're going to scroll down until you see run in terminal right here, and make sure that this has a check mark on it, exactly like this. And then what you'll be able to do is take your main little Hello World program and directly run it in the terminal just by clicking on this little play button up here. And there you go. That is the end of my video. If you want to recommend what my next language should be, I'm going to be making absolutely huge videos like this for all the programming languages out there. So, like always, please leave your questions and comments down below. Otherwise, till next time.